Greetings, warm welcome to this session. I trust all of you are doing good and you are enjoying the learning on this YouTube channel. So here we go with another lecture on linear equation. Let's see it from entrance perspective. What is the importance of this topic? See, from school, you understand that when you see this particular topic, it is more about constructing the equation, right? So it's not just about constructing the equation. See, technically in the school, when you learn, so you learn already what you learn from this chapter is how to construct equation, basically word-based problems we call them, right? So, and you learn more from the words, you construct the equation and then you kind of solve those equations, and we always start from the linearity of the equations, then we move on to the quadratic equations, and some of you, yes, you go up to the cubic equations at times, by quadratic equations, things so on and so forth. So let's go back from the exam perspective. Let us learn today what is the importance of this particular topic. If there are about couple of questions, direct questions on linear equations, how do they look like and what is the nature of these particular questions? So even before that, let me just take some time to recap what is this linearity of equation is all about. Let me recap this without taking it for granted. Although I'm much aware that you must be, since you are preparing for this entrance exam, you would be more or less pretty aware of how to solve the linearity and at least the quadratic parts of the equation. But let me not take it for granted. Let me brief you about what is the background to this. So here we go. Linear is nothing but a straight line, basically a relative graph wise. If you look at the graph from perspective, what is the linear equation? Linear equation depicts a straight line, just like a quadratic equation talks about a parabola, as you might be seeing. So linearity of the equation depicts a particular straight line. Of course, the linear in what sense? So with two variables, right? Ax plus by is equal to c. So when we see this, so this is the one that we talk about, right? So any equation of this particular form where a, b, c has to be real, a, b, and c, they should be real. Of course, all of you would be understanding a little bit about the real and imaginary part of the numbers. Of course, I'm talking about the real part of the numbers. A, B, C are real. At least one of this A and B should be non-zero, because it shouldn't happen that both A and B are zeros here. Both A and B should not be zero. At least one of them should be non-zero. One of the values either of A or of B, one of them should be non-zero. Both should not be zero. Then you'll end up with a constant number. If A is 0 and B is 0, only c is a non-zero number, then you end up with a constant, right? So therefore one of them should not be zero. Of course, as you might be knowing, x and y are variables. On the graph sheet they talk about the x-axis and y-axis, etc., right? So that's about it. So that's a basic understanding of the linearity of the equation. Let's understand a little deeper. So what is that simultaneous linear equation that we kind of talk about, right? At times we talk about the simultaneous linear equation. Even before that, let's understand the graph. It might look like, if I take a simple equation where x plus y is equal to 7. So if I take a linear is degree is 1, the power of x is 1 and the power of y is 1. The degree of the elements of the equation has to be, terms of the equation has to be 1. So therefore this is the linear equation, x plus y is equal to 7. If you just plot it on the graph sheet, if you take a graph sheet, probably most of you would have done this in the school. If you take a graph sheet and if you start giving, so of course it can take all the real values. Can I give the value of x as 1.5? Of course you can. So from plotting perspective, I'm illustrating by taking some simple good numbers. If x is equal to 1, y is equal to 6, if I keep plotting these particular numbers, this is the straight line that you kind of get. All of this is the kind of a straight line that you get. The equation of this particular line is nothing but x plus y is equal to 7. That is the equation of this particular line. So there is a line in the plane. If I were to write the equation for this is how it kind of looks like, right? So that's a basic part of it. That's something that you have to understand. So like as you said, linear equation with one variable. All right, what do we mean by linear equation with one variable? A linear equation with one variable is there is no y. We spoke about that. Ax plus by is equal to c. What did I do here? The value of c is 0. So if the value of c is 0, then finally when you solve one equation with a variable, you end up getting x is equal to 2. Oh, is that a straight line? Of course yes. Of course, as x is equal to 2 is a straight line. If you take a graph sheet, and plot these lines as this is 1, this is 2, this is 3, x is equal to 2 implies this is the straight line. X is equal to 2 implies this is the line which is called as x is equal to 2. The meaning of this particular line is x is equal to 2. It's a vertical line. X is equal to 2 is a vertical line. Had you got y is equal to 2, let's say that, okay, you solved another equation, and had you got y is equal to 2, it might have looked like this. All right, now here this could be the line. This horizontal line could be called y is equal to 2. That could be the horizontal line, right? So therefore linearity of the equation is nothing but the straight line as we understood, as long as the one of the variables, at least one of the variables of one of the at least coefficient of one of the variables is not 0. Well, all right, simultaneous linear equations. What if I have two simultaneous linear equations? There are two straight lines. Basically, we talk about two straight lines. With two straight lines, three cases are possible. There are three cases possible. We'll come back to this particular slide. Here, the importance is I'm presuming that all of you know how to solve this, how to solve simultaneous equation and get me the values of x and y. I'm assuming that we all might know how to solve this. So if required, I'll come back to this at a later part of the lecture. For now, let's understand that, okay, we know how to solve two simultaneous equations and find the answer to this. Okay, so if there are two simultaneous equations, what are the possibilities? There are three possibilities. Let's explore all three possibilities. Technically, what I'm trying to say, if there are two straight lines, first one is a straight line, 2x plus 3y is equal to 11 is a straight line. Let me call it as the line number 1. And I have another straight line. That's a line number 2. There are two straight lines. There are three possibilities with two straight lines. What are the three possibilities? One, the lines can intersect, as I'm showing it in this particular diagram. The lines may intersect. If there are two straight lines, the two straight lines intersect. Okay, here itself, let me brief you. What are the three things that can happen if I have two straight lines? If I have two straight lines, either they may be intersecting or they may run parallel. They may run parallel. They never meet, just like a railway track. They never meet two straight lines, or they are going straight and they never meet. Possible, that's called as a parallel lines. Given two lines, this is another possibility. Third line is probably, all right, now one line is falling above the another line. That is also another possibility. What if both the straight lines are right here? Possible, all right, because I gave two equations of the line. Finally it ended up being one line being upon the another line. That's quite possible. These are the three possibilities. Okay, so now, if it is an intersecting line, there is a condition. What is that I'm talking about? First, let us say that if I have a1x b1y is equal to C1. Let's say that this is line number 1. This is the first line number 1. And if I have A2x plus B2y is equal to C2. Let me call this as line number 2. Let's keep this in mind. All right, for now, let's keep this in mind. If I have these these are the two equations of the line. So how do I understand one look at these particular equation? What is the nature of the line that I'm going to get? Will I be getting the type 1 kind of line? Type 1 is the intersecting line. All right, will I be getting the type 2 kind of a line? What is the type 2 kind of a line? The parallel line, right? Will I be getting the type 3 kind of a line? So therefore, all right, how do I understand this? By looking at the coefficients of x, y and the constant term, will be able to understand that. So for the first condition, for the intersecting line, for the first one, type 1 is what? Intersecting line. One look at the equation, I'll be able to understand that fact first, right? For the intersecting line, well, that's going to be a1 by a2. Condition a1 by a2 should not be equal to b1 by b2. What is a1 by a2? Ratio of coefficient of x should not be equal to ratio of coefficient of y. If a1 by a2 is not equal to b1 by b2, the lines would definitely meet. They are no more parallel. The lines are definitely going to meet. All right, that is what we say here, right? That is the condition. So look at this here. All right, now I have two equations. What is the coefficient of x here? It is 1. What is the coefficient of x in the second one? 1. Therefore, what is a1 by a2 here? 1 by 1. a1 by a2 is nothing but 1 by 1. Okay, what is the b1 value here? Minus 1. What is the b1 value here? Minus 1. Hey, what is the b2 value here? 1. Okay, so is a1 by a2 is equal to b1 by b2? Of course not. Of course not, because 1 by 1 is not equal to minus 1. What is 1 by 1? 1. Is 1 equal to minus 1? Of course not. Therefore, the lines have to intersect. So here I have shown it by using a graph. By using a graph, I've shown that, hey, they are meeting at a particular point out here. They are meeting at one particular point. When you draw it, when they draw the graph to the scale, they are meeting at a particular point, right? That is the first condition. Let's take a look at the second condition out here. Then we will see the graphs in a while. Second one. When do I say that the lines are parallel? When do we say that the lines are parallel? When a1 by a2 is also equal to b1 by b2. a1 by a2 is also equal to b1 by b2, but not equal to c1 by c2. a1 by a2, that is the ratio of the coefficient of x, are matching with the ratio of coefficient of y, but they are not equal. But the ratio of constant terms are not matching. That gives me the type 2 kind of a line. That is the condition for the lines to understand that they are parallel. Now listen to this, guys. If the lines intersect, there is going to be a unique solution. there is going to be a unique solution. So if the lines intersect here, there is one single value of x and y which satisfies both the lines. There is only one single value. Hey, what if I take a value here? What if this particular point satisfies only one line? This satisfies only one line, which is this line, x plus y is equal to 7. It satisfies only one line, but it does not satisfy the other line, right? If I take a point here, or what if I take a point here? If you take a point here, it satisfies only one line, but it does not satisfy the other line. So that is what you mean by the unique solution. What do you mean by unique solution? When I resolve them, there is one common point I'm talking about. This common point is possible only when a1 by a2 is not equal to b1 by b2, right? That's the point I'm trying to make. Let's look at the type 2 line. Type 2 line is what? The parallel lines. This is the condition for parallel line. Just keep these conditions in mind. I will show the next graph so that already it will be much more lucid. It would be much more clearer to you what I'm talking here. All right, what I'm talking would be much more clearer. So let's take a look at the next graph out here. Right, let's take a look at this particular graph. Let's understand this from this graph. So what has happened here? There are a set of two parallel lines. There are two equations that I have. Right, these are my two equations. What is the coefficient of first one? This, let me call it of the nature a1x plus b1y is equal to c1 respectively. Similarly, let me call this particular line as a2x plus b2y is equal to c2. Let us take a look at this. What is the coefficient of a1 and a2? 1 by 1. Ratio of the coefficients is 1 by 1. What is the ratio of coefficients of b1 and b2? That is also 1 by 1. That is also 1 by 1. These two are equal, but it is not equal to ratio of the constants, which is 10 divided by 7. Therefore, we have drawn the lines which are parallel. What do you mean by the solutions? It has zero solutions. Number of solutions which satisfy both the equations simultaneously is 0. Why? Because if there is a point on this particular line, this lies only on this line, but it will not lie on the other line. What if I take a point on this particular line? Then it satisfies the first one of the lines, but it does not satisfy the other line. And hence we say that there are going to be zero solutions if the lines are parallel, because the point will lie either one of the lines or on the other line. There cannot be a single point which can lie on both lines together, right? That's what we mean by the type 2 kind of a line. Okay, type 3, if I take two equations, simultaneous equations, what is the third thing that can happen? The third thing is the lines can be coincident lines. Coincident lines means one line is upon the other line as well. Coincident lines. So what is the condition? This is the condition. So we already understood all two equations. This is the condition. When ratio of the coefficient of x match with y and they also match with a constant term, then we say that the lines are nothing but the coincident lines, which means one line lies upon the other line. So take a look at these equations. All right, what is the coefficient of x? Ratio of the coefficient a1, let me call this as a1 1. What is the a2? A2 is nothing but 3. Therefore you are saying that in a1 by a2 it is 1 divided by 3. What about b1 by b2? This is 1 and this is 3. Therefore this is also 1 by 3. All right. Here, what is the constant term c1 by c2? There is a 7 and there is a 21. Therefore you are saying that this is 7 divided by 21. Put together, are all of them are equal? Yes, they are all equal to 1 by 3, and hence you say that these are the coincident line. Nothing but one line is upon the other line. How many solutions I will have? Many solutions. In fact, we call it as infinite number of solutions. Every point is a solution. Because if you say that there is a point which lies on one of the lines, then the same point lies on the other line as well. Sometimes based on this simple understanding, some questions were asked. All right, some questions were asked based on this superficial understanding. Only this understanding, some questions were asked. Let's take a look at that. Let's take one of the examples built on this. Look at this. For what value of k will the lines represented by the following equations be parallel lines? So you just have to understand the condition for parallelity, right? So if the two lines are said to be parallel, when so only all two lines are said to be parallel if a1 by a2 is also equal to b1 by b2 but not equal to c1 by c2. Here anyway you notice that c1 and c2 are not equal. They are 7 and 10. Therefore you just have to ensure that a1 by a2 should be equal to b1 by b2. Let's understand this. What is a1? 8. What is a2? 4. Here we are. a1 is 8 and a2 is 4. a1 and a2 are 8 and 4. Okay, what about b1 and b2? b1 is k. Let b1 is k here, k. Yeah, what about b2? Minus 7. b2 is minus 7. They should be equal. Anyway, we ascertained that c1 and c2 are not equal. c1 and c2 are 7 by 10, which is not equal to 8 by 4. It is not equal to 8 by 4. 7 by 10 is not equal to 8 by 4 because one of the values is there. Therefore, they are going to be parallel. I just have to find the suitable value of k. Fair enough. Therefore, what is the suitable value of k? Therefore, the suitable value of k is minus 14. When we resolve this, we'll get the suitable value of k as minus 14. So that's the one of the simplest question being asked. There are questions which are built upon this concept of basic understanding of lines. That is one type of question you also get there. All right, that is one of the types of question. Very simple question. I have not take too many examples built on this particular question because you understood that, hey, once I understand these three conditions, there is nothing much all right that can be done out here. So let us quickly take a recap of this. So all you have is what? If the lines are going to be, all right, if the lines have the unique solution, then this is all I need to understand. We need to understand that a1 by a2 should not be equal to b1 by b2. That is, ratio of coefficient of x should not be equal to ratio of coefficient of y. That's one condition. Second one, what if the lines are parallel? If the lines are parallel, the ratio of coefficient of x should be equal to ratio of coefficient of y, but in turn it should not be equal to the constant term, ratio of the constant term. So what about the coincident lines? The coincident line says ratio of coefficient of x should match with the ratio of coefficient of y, which in turn should be equal to the ratio of the constant term. So these are the three conditions. So these are the three conditions based on which at times very simple examples can be created. Let's understand there is certain special cases when it comes to some of the numbers. Let's take a look at this. Let's take a look at this example here. Okay, all of you, I'm aware that okay, you might be able to work with the linear simultaneous equation. Two methods. One, we generally use the substitution method. Substitution method, you may be aware. So x is already here. What is the first equation? X is equal to 3y. X is nothing but 3y. So that is one way of doing it. One equation, you substitute in the other equation. That is one method. X is nothing but 3y. You come back here, you represent this 2 here. Here, what is the value of x? X is nothing but 3y. And then plus here, as it is this plus. And then you carry on this particular y, which is equal to 21. Therefore, you say that 7y is equal to 21. Therefore, y is equal to 3. Once you know the value of y is equal to 3, you substitute it back out here. You substitute this back out here. Therefore, you would say that x is equal to 3 times of y value is nothing but 3, which is nothing but 9. That is, one is what? Substitution method. The second one is what? The elimination method. What do you mean by elimination? You eliminate one of the values. First, you got to decide, should I eliminate x or should I eliminate y? Assume that I decided I will eliminate x. You will eliminate x. You decided eliminate x. You can say that I eliminate y as well. Elimination method, eliminate x. Right, you would say that I eliminate x. Okay, I'm not taking it for granted. I know that all of you, those who are listening to me, you are aware of this, but without taking it for granted, I decided that I will just show you one example. Right, what is the elimination method? You got to decide in your mind first, should I eliminate x or should I eliminate y? So you might have decided, let me decide. I decided that I will eliminate x. If I want to eliminate x, multiply both the equations by the ratio of the reverse coefficients. Now look at the coefficient of x2 here. Look at the coefficient of x, solid legs in the second one, 3. What you got to do? Multiply the entire equation by the reverse of the coefficients. So in the sense, multiply the first equation by 3, multiply the first equation by 3, multiply the second equation by 2, entire first equation by 3, and the entire second equation by 2. Let me rewrite the first equation. Therefore, how does my first equation look like in that particular case? First equation would become 6x. First equation would become 6x plus 9y is equal to 18. This is my 1a. Let me write it as 1a. Right, that is my first equation. What about my second equation? That would become 6x plus 10y is equal to 30. All right, let me call this as 2a because it was the second equation. After doing or after multiplying by 2, this is what I'm getting. Surely, all right, now what do I do? Subtract the first equation from the second. Let us say that let me subtract this. Let me subtract the first equation from the second. 6 and 6 are getting cancelled. 10 minus y, 10y minus 9y is becoming 1y. All right, that is 1y. 30 minus 18, which is becoming 12. Therefore, you first got the value of 12. First, you got the value of 12. All right. Once I get the value of 12, what do I do? Now you go and substitute in one of the equation. Let's say that let me decide to substitute in the first equation. No worries. First equation is what? 2x plus 3y is equal to 6. What do I know in this? I know the value of y here. So therefore, I go and plug this value of y out here. Therefore, 2x plus 3 times of 12 is also nothing but 6. So therefore you would say that 2x is nothing but 2x is nothing but 36 6 minus 36, which will become minus 30. Therefore x is equal to minus 15. This is the elimination method. Elimination is what you can decide whether you want to eliminate x or you want to eliminate y. Eliminate one of them by using the reverse, by multiplying both the equations by reverse coefficients, and then proceed from there and get the remaining value. Right, let's proceed from here. Let us get into the true lecture now. Let's get into the true lecture from here. Let's get into the true lecture. Let's understand. Let's come to the exam perspective. What is the importance of this? Knowing all this background, what I gave is I gave a nice background for the last 20 minutes. I gave a background to this particular study. So let's get on to the study. First, let's take this example. Simple example. Let's understand. So what are the elements that you need to be aware of while you are talking about, while you are dealing with these, dealing with the equations? What are certain elements you need to be aware of? Let's take this example. 4 oranges and 5 mangoes cost 47. 8 oranges and 7 mangoes cost 73. What is the price of 1 mango and 1 orange? That's a set of mango and an orange. There is a set. Already in that set there is a mango and there is an orange. So let me say the orange is x rupees. Each orange costs x rupees. Each mango cost y rupees. So therefore value of 4 oranges is 4x, value of 5 mangoes is 5y. What is the cost here? 47. Okay, nowhere in the market you get it at this price. 4 oranges and 5 mangoes are, you don't get it at 47. So let's assume it to be like that. All right, yeah, let's you try to get practical, then you will laugh at it saying, hey, do I get the 4 mangoes, 5 mangoes and 4 oranges at 47? You don't. I and you are aware that we don't. All right, let's come to the next point, next one. So say 8 oranges, second point, 8 oranges and 7 mangoes. Therefore you are saying that 8x plus 7y. So the charges here, the cost is 73. All right, so what you do at times is just look at the, be aware here after that, be sensitive to the coefficients, etc. So we can, one way of dealing with this is, sure, I can find the value of x, I can find the value of y, and then I can x plus y. So what is that author is expected? 1 mango and 1 orange. Therefore author is saying that, why don't you tell me what is the value of x plus y out here? Right, so if you just already be sensitive to the numbers here after, if you are sensitive to the numbers, just give me a second, friends. Yeah. All right, if you are sensitive to the numbers, you understand that, hey, adding will make sense, because so earlier we said that, hey, we have to get rid of either x first or y next. All right, you don't have to necessarily, we don't have to be observant about the numbers and be observant about the question stem. Author is also not interested what is x and what is y. Instead, author himself is interested in what is x plus y put together. So therefore you would say that 4x and 8y, just add them. By adding, all right, we get benefited. So it becomes 12x and 12y, all right, which is nothing but 120 rupees. Therefore divide throughout by 12, you get a pair of x and y. So divide 120 by 12, you get it at 10 rupees. You get this pair at 10 rupees. An apple and an orange, you get it at 10. So point here is, so this itself need not be a question. Such numbers you will see as a part of some other question. You will find it as a part of some larger picture. This can be a small picture as a part of a larger picture that you can find. But be observant about the numbers. The point I'm trying to make is be observant and be sensitive that, is author interested in individual values, or is the author is interested in a pair put together? That's called as the derived equations. We technically call this, study this in algebra as a part of derived equation. Now don't worry too much about it. That's a separate study in itself. When the time is reap, we will talk about derived equations. For now, let's understand that, let me be sensitive to numbers and let me learn to work with them. All right, let's go to the next case out here, friends. Let's go to the next case out here. So what does it say? The cost of 17 pencils and 13 erasers is 73. Let's understand and write this again. 17 pencils. Let's learn a couple of learning points. Okay, even before I deal with this particular equation, now listen to me carefully. If I have two variables a and b, The value sum of a and b is sum of a and b is 18. Let me call this sum of a and b is 18. A minus b, a minus b is equal to 12. A minus b is equal to 12. If you see this, which means there are two variables a and b, there is only a sign change between the two. There is only a sign change between the two. A plus b is 18, a minus b is equal to 12. If you have this situation, finding a is easier. So what is a? A is nothing but the average, 18 plus 12 divided by 2. That's how you get your a. If you find this nature of this equation, a plus b is 18, a minus b is 12, you can do it in your mind. Just add them and take their average. What about b? How do I get the value of b from here? The value of b here is take the difference and divide it by 2. Take the difference and divide by 2. If a plus b is 18 and a minus b is 12, just add them and divide by 2. You will get the value of a. You get the first variable value. How do I get the second variable value? Second variable value, take the difference, 18 minus 12, take the difference between the numbers and divide it by 2. This is the must know. This is the must know. Anybody working with the equation, this is the must know, which you will be kind of taught in the high school itself, right? High school itself. Sure, all right, some of you would have conveniently forgotten about it. That's a different thing. But yes, this is the must know factor. It is a must know. Some of them are good to know. Some of them are must know. Some of them are must. So therefore, this is one of the must and should everybody should know. Let's come back to the question. Now let's go to the question here. Let's read it carefully. 17 pencils and 13 erasers. Let me take each pencil as x rupees, each eraser as y rupees. Thereby 17x plus 13y is equal to 73. 73. Second portion, the cost of 13 pencils, that is 13x, and 17 erasers, that is 17y, which is equal to 77. Which is equal to 77. Just add them. We just understood that let's be sensitive from the previous point. We understood that let's be kind of sensitive to numbers. Therefore, you would say that, okay, this is nothing but 20x plus 20y. You would say, now 20x, you're adding them. First thing is you're adding them. When you're adding, you're getting 20x plus 20y is also nothing but 150. What you are getting is this 17 and 13. Therefore it's nothing but 150. 20x and 20y are 150. You can get the value of x and y from here. You can get the value of x and y from here. The value of therefore the value of x and y is nothing but 15 divided by 2. You can write it as 7.5. Sure, let's keep this 7.5. Let's write the same side. What we do is just take the difference between them, friends. Let me write once again for you in case you are getting confused. 17x plus 13y is equal to 73. That is one equation there. Then we had 13x plus 17y is equal to 77. It is equal to 77. Let me take the difference between them. So what I do here is, let's take the difference, minus. Let us take the minus values here. So when I take the minus, you get it as 4x. You are taking the difference, minus 4y. 4x minus 4y is equal to minus 4. You are subtracting the second one from the first one. I subtracted the second from the first. Divide throughout by y. If I divide throughout by y, I end up getting x minus y is also nothing but minus 1. X minus y is nothing but minus 1. This is what you end up getting it. So coming back to this, copy it down here. So you are getting into this particular shape. What you had earlier, what we discussed earlier, we are getting onto that particular shape. Therefore, you are saying that x minus y is equal to minus 1. X minus y is equal to minus 1. How do I get the value of x from here? The value of x is 7.5 plus the value is minus 1 divided by 2. That is the value of x. Value of y, let me show you what to calculate there, right? The value of y is nothing but 7.5 minus of minus 1 divided by 2. This is how you are getting the values of x and y. Okay, all calculation is simple here. 6.5 divided by 2. We can do that. I showed you how to write the averages here. Whatever we learned earlier, I'm just showing that how the numbers would have been tricked into the gone into the perspective, rather than trying to solve and find the values of x and y from this cumbersome equation where you end up multiplying 17 with 13, 13 with 17, right? And then the numbers will become literally explode and become larger. Instead of exploding the numbers, the easier way is, we learned some trick in the previous question. Saying that let's be observant with respect to numbers. We talked about it. Let's be observant. Once you're observant with this particular number, then we are aware of another concept there, right? As we are aware of another concept out here. So using this particular concept, putting them together, so you are able to resolve this issue much faster and much better. right? Okay, so you kind of got the perspective. I think you got the overview of this. So calculation should not be a worry, because this is 6.5 divided by 2. If you really want to calculate this, put the answer, nail down the answer here. 6.5 divided by 2, all it, which is nothing but 3.25. 3.25. If you want to understand why, all of that becomes 8.5 divided by 2, which is 8.5 divided by 2, which would become 4.25. Getting the answers is not a problem out here. The all it, method is the issue. All it, no, so method is the issue. If you are not aware of better way of dealing with this particular problem, it simply irritates a little bit, right? Now it becomes a little irritant, in the sense you start working with unnecessarily larger numbers. Resolving would take a little more time. So rather, most of the mental calculation will happen the moment you are aware of certain methods. Okay, I hope everybody is appreciating and enjoying this. Let's go further. Let's go further. Let's go further. Here we go, guys. Let's understand another one. Let's understand another one. Okay, I could have read, I would have put words around this. I would have put words around this, but I thought let me quickly make you aware of the special case, just like how you learned some of the special things in the last two examples. In the similar way, let's also just be aware. I can put words behind this. I can say that, hey, the cost of three apples, and the cost of three pencils, the cost of three pencils and four erasers is 21 rupees, and the cost of 12 pencils and five erasers is 84 rupees. I can put words around this, but I thought that let me quickly make you aware of all it, what is the speciality of these particular examples and how we can work faster with them. See, sometimes at times what happens is you kind of find that some of the ratios would be constant. I want you to be careful with the numbers. If you watch my video on percentages 1, I already made you aware that, hey, you need to be sensitive to numbers. You need to be a little sensitive. If you're not sensitive to the numbers, you'll be lost in the sea. It's kind of you're lost in the sea. So be sensitive to numbers. It definitely helps you in cracking the questions faster and better. Now take a look at this. What is happening here? Some of the coefficient ratios are matching, especially right now here you say that the ratio of coefficient of x is 1 by 2. Ratio of coefficient of x is 1 by 2. You look at the ratio of the coefficient of the constant terms, friends. No, so sorry, ratio of coefficient of x is 1 by 4. Look at the ratio of the coefficient of constant terms, that is also 1 by 4. If the one of the variable coefficient of one of the variables match with the constant term, the y can be found out faster. Y can be found out faster. What I meant, hey, if the ratio of x are matching, if the ratio of x are matching, then y can be found out. If the ratio of x are matching with the constant term, because if the ratio of x is matching with the ratio of y, it becomes a parallel line. There is no solution to that. See, what I'm trying to say, the ratio of constant terms, that is a1 by a2, we already talked about it. Register that in your mind. a1x plus b1y plus c1 is the first line, a2x plus b2y plus c2 is the second line. Register that. When I'm writing a1 and a2, I'm talking about the x, right? I'm talking about the x portion of the word, x portion of it. All right, and the constant term, if that is equal to c1 by c2. If this is true, if a1 by a2 is equal to c1 by c1 by c2, you can quickly find y. All right, quickly find y without much hassle, much effort. You can quickly find this y. You can quickly find this y. Let's see how. Let's see how. So all you got to do is go back to the equation. So now here we understood that the ratio of coefficient of x is matching with the constant term. Just all it now. So all you got to do is equate them, equate both of them. Just multiply the first equation by 4. Multiply the first equation by 4. You will understand what happens there. If you multiply the first equation by 4, you understand that 12x, I'm just writing the first equation, guys. 1a I'm writing 1a here, I'm writing 1a here. So I'm writing the 1a. 12x plus 16y, 12x plus 16y is equal to 84. 12x plus 16y is equal to 84. Write the second one, 2 as it is. I'm copying 2 as it is. 2 is nothing but 12x plus 5y is equal to 84. Now let me solve this. 12x and 12x are cancelled. Assume that I'm subtracting the second equation. 12x and 12x are cancelled. 84 and 84 is becoming 0. Therefore, you are trying to say that, hey, the value of 11y is equal to 0. Therefore, what is the value of y? 0. That's a point I'm trying to make. That's a point I tried to say, that a value of y can be quickly figured out. What do you mean by quickly figured out? I meant that the value of y is going to be 0. I meant that the value of y is going to be 0. So that is another special case. Whenever you find that a1 by a2 is equal to c1 by c2, the other variable is 0. Although this is there, it is free. Basically it is free, which means if you buy pens, I will give pencils free. There is some offer, there is some deal which is going on, something like that. All right, now for X I charge, for Y I will not charge. That is coming out for free. All right, that portion is coming out for free, something like that. Okay, so therefore you can find the value of X directly from here. Therefore the value of X can be directly found out from here, in the sense once you understand that Y is 0, insignificant, then entire 3X is nothing but 21. Therefore you are trying to say that, man, 3X is equal to 21. Therefore you will quickly find the value of X from here. All right, you will say that the X value is nothing but 7. All right, either you take the first equation or you take the second equation, it does not matter. Basically the Y is coming for free. All right, some of the items are coming for free, just like buy one get one free kind of offers, something like that. All right, if something is coming for free, take a look at the second one with a similar understanding. Take a look at the second one. Let's see that is there something matching in the second one. Yes, the ratio of coefficients of Y's are matching here. Now look at this. This is nothing but 2 by 5. 2 2 times and 2 5 times. This is also nothing but 3 2 times and 3 5 times. So what is happening here? The ratio of coefficients of Y's are matching this time. That is B1 by B2 is also equal to C1 by C2. In that case, what will be 0? In that case, X is going to be 0. In that case, all right, in that case, X is going to be 0. So therefore I don't have to solve for this. X is going to be 0. The moment X is 0, take one of the equations. Take one of the equations and get the value of Y. So you are trying to say that 4Y is equal to 6. Therefore Y is nothing but 1.5. All right, Y is nothing but 1.5 and X is nothing but 0. Right, yeah, keep these kind of cases in the mind. All right, it's good to have these kind of understanding, because when you get into the larger picture, you see some numbers. If you are already, if you are attentive to those particular numbers, you'll be able to quickly figure out some of the variables in the larger picture. Right, it's a small setup. See, the examples that I'm giving is a very small setup. As you get on, all right, as you progress in your preparation, you get into some larger setup. Now in the larger setup, these are the elements. Some of these things will come as the elements of that larger setup. That's where these things come handy and where you start saving some time, because sometimes you'll be wondering, man, I am taking 3 minutes to do this question, why some other fellow is able to do it in 1.5 minutes? But the point here is the small elements, they have the control. In the larger setup, when I use these small elements, these small pieces of understanding, I'll be able to resolve the larger setup in the faster manner. All right, that's a whole idea there. Right, yeah, let's go further. Let's go further. I hope you are enjoying this. You are enjoying this, learning some things here. Okay, let's take a look at this. Consecutive numbers. Sometimes you will get some questions built on consecutive numbers. Sure, those who are comfortable with progressions, the moment you understand the consecutive numbers, listen guys, the moment you get a consecutive numbers, understand it's nothing but an arithmetic progression. That is the trigger. Understand that it is nothing but the AP. You got to quickly understand that, okay, we are talking about AP. At times, this is the point which you miss. This is the point that you are going to miss. You will fail to understand that you take consecutive natural numbers as consecutive natural numbers, but somewhere you fail to understand that it's an AP series. Now, what are the couple of things about the AC series? Let's understand the common basics of AP series. There are terms here in the AP series. There would be terms, 3 terms, 4 terms, 5 terms, whatever be it. All right, there would be terms here. All of you understand that what is the AP series. Let's say first number is 1. Then I wrote the next number, which is 4. Then I wrote the next number, all right, which is going to be 7. You understood, hey, the difference has to be constant. All right, you all would be knowing it. The difference has to be constant. The difference is 3. The difference is 3. Therefore, you can continue to write this particular series. This is 10 and this is 13. Okay, I'm not talking about consecutive numbers. I'll come to it in a while. So I'm talking about an AP series. Point here is consecutive numbers are also AP series, right? The common difference here, we wrote the common difference for this AP series. If I ask you, what is the arithmetic mean of this particular series? All right, there are very simple terms you would have learned from your high school, right? Don't panic because, hey, am I discussing progressions all of a sudden here? No, I'm discussing very superficial area of progressions, which is about consecutive terms, consecutive odd terms, consecutive even terms, consecutive numbers, right? I'm talking very superficial area of progressions. I'm not going anywhere closer to progression. Let's take a look here. So what is arithmetic mean? If there are odd number of observations, how many observations are here? Only 5 observations. Odd number of observations. If there are odd number of observations, the middle term is nothing but the arithmetic mean. Middle term is nothing but the arithmetic mean. That is one way of finding the arithmetic mean, right? Yeah. Hey, what is the other way of finding the arithmetic mean? You can add the first term and the last term divided by 2. That is another way of finding the arithmetic mean. First and the last, which implies that I do 1 plus 13 divided by 2? Yes, the first term and the last term. 1 plus 13 divided by 2 also becomes my arithmetic mean. You can also, arithmetic mean also can be found out like this. The second term and the second last term. You can also use the second term along with the second last term. Second term with the second last term also gives the arithmetic mean. See, you got to be taking in the patterned manner. That's important. What is the second term? 4. What is the second last term? 10. So therefore I can also get my arithmetic mean as 4 plus 10 divided by 2. 4 plus 10 divided by 2, therefore which also becomes 7. So now these are the simple things you learnt in the arithmetic progression, right? If there are odd number of terms, the very middle term becomes the arithmetic mean. Or I can take the first and the last divided by 2. Hey, why you divided by 2? Because you added only two numbers. When you added two numbers, you have to divide by 2 for the average. You can't divide by 3 after adding two numbers because you just added only two numbers out there, right? Yeah. So but then you have to add it in pattern. Can I add any two numbers? No, not any two numbers. If you consider the first, you better consider the last. If you consider the second, you better consider the second last. There should be a pattern to it, right? There should be a pattern to it. I hope everybody is understanding this. Everybody is understanding this. Let me take six terms here. Let me take six terms here. Let me take six terms here. So why I'm saying all this? Because I'm going to show the applications built on this. Let me take some six terms here. So let me continue this. 1, 4, 7, 10. There is a 13 and 16. Hey, what is the arithmetic mean of this? Arithmetic mean of this, some of you will say that, hey, two middle terms divided by 2. I will add the two middle terms divided by 2. Perfect. All right, that's also fine. Arithmetic mean is nothing but two middle terms divided by 2. 17 divided by 2, which is 8.5. Not only that, hey, you can add the first and the last term divided by 2. There is no problem. What I'm trying to say, 1 plus 16 divided by 2. That also gives you the answer. Hey, not only that, even 4 plus 13 divided by 2 also gives the arithmetic mean. Okay, I guess all of you are getting the pattern. Let's now get on to this. Are the consecutive even numbers, consecutive odd numbers, do they also fall under the arithmetic progression? Of course, yes. Consecutive natural numbers, write from anywhere that you like. Write from anywhere that you like. Right? What do you mean by write from anywhere? Write anywhere. 10. All right, I wrote 10, 11, 12, 13, 14. Are they in AP? Of course they're in AP, because the common difference is 1. Common difference is 1. You went on to increase it by 1. Common difference is 1, right? Yeah. Similarly, let's say that what if I write the even natural numbers? All right, that is 10. Consecutive even natural numbers, 10, 12, 14 and 16. Are they in AP? Of course yes, because the common difference is 2. Similarly for odd series like 11, 13, 15, 17, will they be in arithmetic progression? Yes, they would be in arithmetic progression. They also would be in arithmetic progression. Simple part. I just refreshed your memory with the arithmetic progression. All right, I refreshed your memory. Let's go ahead. Let's understand one more part before we deal into a couple of questions built on this consecutive nature. Before we deal into these questions, let me update you with one more point. Let me update you here. Here we go, friends. Let's say, so how do you, all it in the schools, all right, they would have taught you in the schools how to assume terms in the arithmetic progression. What if there are 3 terms in the arithmetic progression? Let me start with 3 terms. If there are 3 terms in the arithmetic progression, classical way of writing is let the first term be A. All right, that's what you would have learned. A is the first alphabet, and you would have learned that let the first term be A and the common difference be D. Already you will say that the common difference between the terms is D. So you will be able to recall from high school that this is A plus D. What is this? This is A plus 2D. I'm helping you to recall. I'm just helping you to recall. It's not that already you are not aware of them. Just in case, I'm just making it clearer to you, right? Yeah, that's how you write. That is one way of writing. What is the common difference? The common difference is D. That's how I would have written. Instead, now here, if I were to write it, what you do is take the middle term as A. Why take it as A plus D? Take the middle term as A. I will tell the advantage why I should be doing this. The middle term as A. The term before this will be A minus D. The term before this will be A minus D. The term after this will be A plus D. The term after this will be A plus D. What is the advantage? Why should I do this? Why should I take the middle term as A? You can take the middle term as D. A, maintain the gap of D. Therefore, the term 1 will become A minus D. It will be D less. What about the term 3? It will be D more, right? It would be D more. So I hope everybody is connecting with this. So therefore, I'll let know. So what is that you are trying to say? Look at the sum. How beautiful it will turn out. If you add these numbers, it will turn out to be 3A. Technically, it becomes one variable. On the other hand, had you taken this and added, had you considered the first term as A, second term as A plus D, third term as A plus 2D, if you add all of them, sum, what I'm writing here is a sum. If you add all of them, it's a mess up. It's a mess up. It would become 3A plus 3D. 3A plus 3D. Technically, what you are trying to say is 2 variables are there. There is an advantage. Lesser the variables, better it is. You'll be able to find the value of that variable faster and better. So therefore, that's an advantage. Therefore, when there are odd number of terms in the series, the middle term I will take it as A, and then I will proceed. All right, these are the small things you learned in the progression chapter, right? Progression chapter. They all go work hand in hand and build all. Therefore, you should not neglect these small areas. Small areas, pretty small areas, Don't go deeper into the concepts of algebra, etc., because you are not writing any IIT JEE entrance exam. The results are away, the results, which results have come, right? You are not writing any IIT JEE entrance exam. All we are writing is a simple management entrance exam, or some of the aptitude entrance exam. For that, I don't have to get deeper into the concept of it, but yes, I should have touched the concept of it. I cannot forget the basic parts of this. Basics I should know. All right, that's a whole idea. Fine, let's come to this. Let's do one last part, and then I'll get into the problem solving on this. Hey, what if there are five terms? What if there are five terms? What if there are five terms? Which one I should be taking? Which all it where I should start my understanding? You have to start your understanding here. Your assumption, you will say that the middle term be a. If the middle term is a, the term before this will be a minus d, d less. Hey, what about the term after this? All right, now the first term, that will be 2d less. This will be 2d less, one at a time, right? Similarly, what about this particular term? This is going to be a plus d. What about this term, last term, a plus 2d? Consecutive, you are maintaining the gap of these. Why did we do that? Assume that if I want the sum of these five terms, all these get cancelled, I'll be simply left with 5a. What do you mean by 5a? 5a is equal to some number which author would have given. So therefore, a is equal to number divided by 5. If I do number divided by 5, what do I get? I will get the middle number. That is what I started. Now look at this question. With that perspective, now let's take a look at this question. All right, I guess all of you understood this. Very simple illustration. I kind of like covered about the progression, the very basic parts of the arithmetic progression in about 7-8 minutes time. Let's take a look at this question. The summation of 5 consecutive integers, I already told you, 5 consecutive. Consecutive means they are in AP. Well, of course, they are in AP. There are 5 consecutive integers, they are in AP. So they are, therefore, technically you would have written it this. You would have written this only. This is the piece of information that you would have written. 5 consecutive integers is how much? 1185. You said that 1185. Instead of this n, here you would have simply written it as 1185. 5a is equal to 1185. Author is asking, man, why don't you tell me the third number? Third number is nothing but the middle number, which is a third number. Therefore, all I could have done in this is just move to 1185 divided by 5. All right, this is all the answer expected. See, that's understanding. The moment you understand that consecutive integers are nothing but they are in AP, and when there are odd number of terms in the AP, the third number is nothing but the middle number. Life would have been so easy. You would have simply looked at this number 1185 and you would have divided this by 5 and you would have done this mentally. Therefore, I said that, hey, the concepts we are learning today are the part of the larger setup. All right, they need not be questions themselves. Sure, if you're writing some of the simpler aptitude tests, this can be a question in itself. But if you're writing, all right, now certain challenging one, all right, challenging test, this is the part of the larger setup. Therefore, I need to understand that, hey, consecutive natural numbers means I need to first, the thing that should come into your mind is consecutive numbers, consecutive even numbers, consecutive odd numbers. The thing that should come into your mind is, okay, we are talking about, all right, we are talking about the arithmetic progression. If that comes to your mind, the life is sorted, right? Life is sorted. Okay, therefore, all right, result is pretty simple here. All right, result is simple. There should not be a concern on writing what is 1185 divided by 2, right, which is nothing but 237. All right, which is nothing but 237. That is the middle number out there. Let's go to the next one. I hope you are getting hang of this. I will do a couple of questions on this concept. Very important concept. I'm not getting into the progressions, depth of the progression. That is a different topic in itself. I'm seeing from the consecutive number, very superficial part of it, what it is. Let's take a look here. Ajay. All right, let's take a very simple question here. Ajay is as much younger in age than Hiren. All right, younger. All right, now who is older between the two? First, let's understand that Ajay is younger than Hiren. Ajay. All right, Ajay is younger. Ajay is younger. Ajay is younger than Hiren. Okay, as he is older than Sanjay. Who? Ajay. Ajay is older than Sanjay. First, when I understand the first statement, let me get this part right. Because if I fail to understand the first statement, the second statement onwards, it doesn't make any sense. What is that he's trying to say? Ajay is as much younger. All right, let me redo that. Ajay is as much younger than Hiren, which means age of Ajay is less than Hiren. Let's understand that first. All right, Hiren. As he is referring to what? Ajay. He is referring to Ajay. Ajay is older. Greater in age. Ajay is older than Sanjay. Therefore, if I ask you, who is the youngest? Sanjay. Sanjay is the youngest fellow. Hey, who is the oldest? Oldest is this. All right, oldest is this. Hiren is the oldest fellow. Right now, finally, I want the age of whom? I want the age of Ajay. I want the age of Ajay. Now pay attention to as much younger difference. As much younger, as he is older. As much younger as he is older. What is that we are trying to say? The difference between H minus A. That's the first part. Is as much younger. If you relate Ajay with Hiren, as much younger means what? Difference H minus A. That is the age by which he is younger. As he is older, what is it referring to? Alright, this is referring to A minus S. They are equal. The difference between their ages are equal. Therefore, H minus A, the difference. When I'm writing three terms, now listen to me. There are three terms that you are writing here. There are three terms that you are writing. There is a first term, there is a second term, and there is a third term. First term is what? Sanjay. Second is what? A. Third is what? H. What you are trying to say? The gap is same. Difference is constant. This difference is same. That is what author has said. This difference is same as this difference, because that's a statement which is made there. The difference between H minus A is also equal to difference between A minus S. That is the statement which is made. Hey, when is it possible? Which means the difference is constant, means their ages are in AP. If their ages are in AP, I know how to find the middle number. How to find the middle number? The middle number is nothing but their sum. I will write the sum. Hey, what is the sum of their ages? Is that given to me? Yes, sum of their ages is given to me. 48 years. All right, now so sum is 48 years. It's given to me. Sum of their ages is 48. Therefore, what is the age of the Ajay? We already know that. Just divide by 3. Just divide by 3. From the previous question, we know it is you just have to divide by 3. Why? Because if Ajay's age is A years, then Sanjay's age is A minus D years, and the Hiren's age is going to be A plus D years. If I add them, D and D gets cancelled. I will never be able to find what is Sanjay's age. I will never be able to find what is Sanjay's age. I will never be able to find what is Hiren's age. But I can find the Ajay's age. Ajay's age is going to be 48 divided by 3, which is 16 years. Right? Ajay's age can be found out. Right? But Hiren and Sanjay's age cannot be found out. For that, we need further information. I guess all of you are learning something here. I guess all of you are learning something. I guess you are learning something. Good. Good. Let's continue. Let's continue. Let's continue. Let's continue. Okay, I will leave a minute here. I will leave a minute here. Beautiful cat question. I will leave a minute here. Beautiful question from the test. I will leave a minute. Think about it. One of the very beautiful questions. Now that you understand a little bit of background about the consecutive nature of numbers, basically AP, all right, progression kind of numbers. They are not consecutive necessarily. Progression. Basically, we are talking about AP. Think about it for a minute. How do you put it to perspective on this question? Yeah, here we go, guys. Fine. It's time. A man 50-year-old has 8 sons born of equal interval. The sum of the ages of the father and sons is 186. What is the age of the eldest son if the youngest one is 3 years old? Let's understand this. All right, there are 8 sons. There is a son 1. Let's put this to perspective. Son 1, son 2, son 3. Likewise, let's say that these are the names. Son 8 is the eldest. Let's say that son 8 is the eldest and son 1 is the youngest. Oh no, all right, now you generally have the habit of writing the other way around. Fine, I will write that way only. Let's say that son 8 is the youngest. Son 7 is the next youngest. Son 6 is the next youngest. Likewise, all right, you finally have the son 1 who is the oldest. Right? Who is the oldest among them. Okay, there are 8 sons and there is a father. And there is a father. What is given to me? He said that, okay, the man is 50-year-old. The man is 50-year-old. The sum of the ages, all right, ages of father and 8 sons put together is 186, which means if I add up all these people, plus, all right, we are adding up all these people. If I add up all these people, including the father, if I add them up, it is becoming 186, of which I know the father, age of the father. I will remove age of the father, I will remove minus 50. All right, minus 50, which would become 136. Therefore, what is this 136? You are saying that youngest child. Next youngest child, right, say 6 like this. Finally up to s1, you are saying that hey, age of these folks is 136. That is nothing but 136. Age of these 8 kids is 136. Now listen to me, this guys, all right, now they are born of equal interval, which means the gap between the numbers is same, therefore they're in AP. That's a word here. They are born of equal interval. What do you mean by born of equal interval? You mean that the gap between their ages is constant. If the gap between their ages is constant, this particular series is in arithmetic progression. Arithmetic progression. Now look at this. What is being asked here? What is the age of the eldest son? If the youngest one is 3 years, if the youngest one is 3 years, what is the age of the what is the age of the eldest son? See, firstly, let me understand what is the arithmetic mean of these numbers. What is the arithmetic mean of these numbers? Understand this very carefully. What is the arithmetic mean of these, or arithmetic mean of the sum of the ages of all the kids? That is, sum is 136. Sum divided by 8 kids, that is also arithmetic mean. That is also nothing but the arithmetic mean. All right, that's arithmetic mean out here. So what do you mean? All right, I meant that okay, the sum is nothing but 136 here. 136. Whose sum? Sum of these 8 kids. Whose sum I'm talking about? Some of these 8 kids I'm talking about. 8 kids divided by 8 kids divided by 8, because there are 8 kids out here. All right, 8 kids, all right, the 136 divided by 8, that is the arithmetic mean, right? That is the arithmetic mean. The same arithmetic mean, right? This is the same arithmetic mean. All right, we can same arithmetic mean can also be written as s1 plus s, all right, s1 plus s8 divided by 2. Youngest son and the oldest son divided by 2 is also arithmetic mean, my friends. This is also nothing but the arithmetic mean. I already know what is the arithmetic mean here, right? I already know arithmetic mean here. Simplify this, simplify this. All right, this will become 16. All right, this, all right, this would, all right, this would become, all right, this 17, right? That would become 17. 17 is the arithmetic mean, right? Yeah, 17 is the arithmetic mean. Therefore I know that son 8 plus son 7, son 1 is together is 17 years. So if that is the case, what is the age of the youngest child here? Youngest child is 3 years. Substitute youngest child, that is s8, is 3 years. The age of this child is known to me, therefore 3 plus s1 divided by 2 is nothing but 17. All right, which is nothing but 17. Therefore 34 minus 3, you are saying that okay, the eldest son therefore is nothing but 34 minus 3, which is nothing but 31 years. All right, which is nothing but 31 years. Let me quickly repeat this. Let me quickly repeat what was the importance, what was the elements of this particular question. The person has said that the kids are born of equal intervals, which means the ages of the children are in AP. Fine, I first figured them out. I wrote them. There are 8 kids and a father. 8 kids and a father. What is the sum of all their ages? Sum of all their ages is 186 years. Out of this, what is the age of the father? The age of the father is 50 years. I subtracted. Age of the father 50 years, I subtracted. Therefore I got the sum of the ages of the kids. What is this? Sum of the ages of all 8 kids put together. We figured out sum of the ages of all 8 kids put together. Can I find their average age? Of course I can find the average age. What is the average age of all these kids? The sum of their ages is 136, and how many kids are there? 8 kids are there. Therefore I got the average. Average is also nothing but arithmetic mean, right? Arithmetic mean, because the progression is in arithmetic, the ages are in arithmetic progression. Therefore you found their average to be 17 years. You found their average to be 17 years. Once their average is 17 years, the arithmetic mean is 17 years. Arithmetic mean can also be found out by using the first son and the last son divided by 2. All right, first and the last divided by 2, because they are in AP. The arithmetic mean is the first term and the last term divided by 2 gives the AP. We already said that. So therefore I added them, I divided by 2. So thereby I got the age of the eldest son. Their eldest son is of 31 years old, right? That is the idea there. Now look, all right, very simple question, but the point is, if you just understand a little bit about the progression, this question can be solved within no time. Solved within no time. While explaining it is taking time, because I'm explaining the concepts to you. The point is, if you're doing it on your own, it hardly takes any time, right? That hardly takes any time. Let's go further, friends. Let's go further. Let's go further. Let's go further. All right, try it out. Try this out. Take 30 seconds. Write at least what you want to write. Let's go here. Find three consecutive even integers. Basically, even integers. Of course, they're in AP. Alright, because author is saying about three consecutive even integers. There are three consecutive even integers. Therefore, they're in AP because of the word consecutive. They're in AP such that if the first is divided by 2, the second by 4, and the third by 2, then the sum of their quotients is going to be 45. That is what author is trying to say. See, look, there are three consecutive numbers. There is a first number, there is a second number, and there is a third number. What is the action? Action is the first number is divided by 2, which means it should be divisible by 2. It should be divisible by 2 because he's adding the quotients. He's adding the quotients and he's saying that, man, that is 45. Well, that is 45, right? The second one must be divisible by 4. Why? Because he only said that the second I am dividing by 4. Second I am dividing by 4. What about the third? Third is divided by 2 again. Third is divided by 2 again. Therefore, what I do is, I know that already we generally make the assumption in the middle term. Therefore, I will say that, man, let the middle term be 4x. You may wonder that, hey, why not take x? What is the problem taking x? I'm saying that, okay, it is divisible by 4. If it is divisible by 4, the second term should be a multiple of 4. This should be a multiple of 4. Why not say that the middle term is the 4x? There is no problem. Middle term, we are supposed to be writing it as a. But hereafter, whenever they get the triggers from the question, get the triggers from the question. Sure, we will take a couple of questions like that as we go along. But understand that better to get the triggers from the question so that you can simplify and quickly do the mental calculations on some of the questions, right? Yeah, so I will take the middle term as 4x, friends. I will take the middle term as 4x. Alright, if I take the 4x, the number before that was 4x minus 2. You may wonder, hey, how do you know it is 4x minus 2? Because it's a consecutive number which is already 2 less. 2 less. The number which came before is going to be 2 less. The number which is to come after is 4x plus 2. It's a easier way, or a traditional approach. Sure, you can take the middle number as x and the number before that as x minus 2, the number after that as x by x plus 2. You can do that, but the point is I would like to take the middle term as 4x because author only said that the middle term is divisible by 4. If it is divisible by 4, then let me take it as 4x itself. Therefore, the term before that I will take it as 4x minus 2. The term after that I will take it as 4x plus 2. Right? This is how I will take. Now let me put the quotients. Let me put the quotients. Quotients means author said divide this by 2. Okay, plus. Let divide this by 2. Let when the first is divided by 2, second you are dividing by 4 plus. Why plus? He is saying that the sum of the quotients is going to be 45. I'm dividing. Okay, this I should divide by what? 2. That should be equal to how much? 45. That should be equal to how much? 45. That is what he said towards the end. Let us see this. What does this become? Therefore, what does this become? This will become 2x minus 1. 2x minus 1. This is the quotient because 4x minus 2 divided by 2. What is the quotient? 2x minus 1. What about the next one? X. Next one is x. Hey, what about the next one? The next one is going to be 2x plus 1. 3x plus 1. What is the value of this? 45. What is the value of this? 45. What is getting cancelled, dear friends? This plus 1 is getting cut off with this minus 1. Therefore, add others. You are saying that 5x is equal to 45. Hey, therefore, what is x? X is nothing but 9. X is nothing but 9. His question is what? Alright, now this is this. If the first is divided by this, then he's saying that divided by this, then their sum is the sum of the quotients is this. Find three consecutive numbers. What are the three consecutive numbers? Simple. The middle number is nothing but 4x here. The middle number. What are my three consecutive numbers? T1, T2 and T3. The middle one is 4x. The one after before that is 4x minus 2. The one after that is 4x plus 2. So I can write it. The x is nothing but 9. Therefore, you are saying that this number is 4 times of 9. Which is nothing but 36, right? And here it is going to be 36 minus 2 because you already know this is 36. 36 minus 2, this number is 34, and the number after this is going to be 38. These were the numbers. See, just because you take them as 4x in your mind, if you make the suitable number, when you read the question, get the triggers. If he's saying divide by 4, divide by 2, write the suitable number. There is no hard and fast rule that you should be writing the variables as x, y, z, etc. There is no hard and fast rule. You can take 4x as a variable, etc. But remember, and come back and close it by using 4x and 4x minus 2, etc. Close it. It happens pretty fast, right? Pretty fast. I'm writing little too much because I have to explain this to you. But had you been doing it for yourself, how long does it take? All you were about to write was these two pieces of information. You can close this question within a minute's time, the time that I gave it to you, right? Yeah, but learn to make suitable assumption. I hope all of you are learning certain approaches on this question. I hope all of you guys are learning certain approaches. Good. Let's shift the gear. Let us shift the gear to certain kind of problems based on ages. All right, so let's shift from these consecutive numbers or a little bit of elementary concept of progression that we have seen, how to get that mileage and the momentum while we are doing some of the equation based questions. Now let's shift our gear to little problems related with ages. Two more. I'm going to teach you about two or three more larger concepts, right? So we have still half the lecture time. So I will teach you another two or three more concepts. With that, all right, we'll close this particular lecture. So we are midway down the lecture. We learned about a couple of, we learned about the basic understanding of them, the intersecting lines, the parallel lines. Then we talked about the lines, all right, now which, all right, one line above the other kind of line, right? So therefore we talked about the basic elements, the conditions related with them. That's where we started our lecture, right? And then all right, now we also explored few questions, few special type of equations based on that, right? We take the special cases. Hey, look, all right, when a1 by a2 is equal to c1 by c2, how y becomes 0, all right, how the y will become 0, things like that. Then I taught you some of the quicker calculations, how you can do certain, all right, if you are observant about the numbers, how you can how you can calculate certain calculations mentally and get to the answers, right? These are the couple of things that you kind of seen while doing these particular questions, right? And then towards the end, just before this, or before just some time back, we also looked at the consecutive nature of the numbers or elementary concept of progression, how it can be useful in some of the questions. I'm teaching the third important point out here. All right, so we'll talk about the ages. I'll not spend much time on this because it's a pretty simple concept, One important thing, don't bother about this question. First listen to me. What is very important thing? The difference between the ages is constant. That is the most important point. The difference between the ages of two individuals is always constant. For example, take you, I'll let you and your sibling or your parent, whatever. I'll let you compare with somebody else. I'll let you versus your sibling. I'll let elder sibling or younger sibling, whatever is that. The difference between your ages, both of your ages is always going to be constant. Your age and your sibling's age is always going to be constant. Let us take an example. Assume that you are 22-year-old. Already you are 22-year-old now. Already you are 22-year-old now. Your sibling, assume that your sibling is 20. Already your sibling is 18-year-old now. Hey, what is the difference between your ages as of now? So what is the difference between your ages? Difference between your ages is 4 years. That's a difference. Difference between your ages is 4 years. Now roll back. Think about it. Hey, when you are 10-year-old, of course your sibling was 6-year-old. Think about it. Your sibling was 6-year-old. The age gap was 4 years. Right from the beginning, all right, the age gap was 4 years between you and your sibling since the time that your sibling is born. All right, otherwise go to the future. Hey, when I become, all right, when I grow old by 4 more years, you would become 26. Then your sibling also grows older by 4 more years. Therefore this fellow will become 22. Your sibling becomes 22. 26 minus 22, it is 4. Remember, the key word, all right, while solving the age related problem is difference between the ages of the individuals is constant. Difference between the ages of any set of individuals is going to be constant. Difference between two individuals, if you take just two as an example here, it's going to be constant. That is the key element, right? Whenever you are stuck with respect to the age problem, this is the concept that you got to utilize. That's a concept you are going to utilize. Fine, let's take a look at this question. What does it mean to us? Let's take a look at this particular question. The sum of ages of mother and a daughter is 31. Let's take a look at this question. Right, mother and daughter is 31. If the age of a daughter is 1 year more than 1/5 of the age of the mother, guys, simple. All right, now how do we solve this question? Technically, most of the simple age related question are solved by using one variable. You don't even know two variables. Two variables are required only when it is critical. Therefore, I will also not do too many simple question on ages, because trust me, age related question, once you understand the premise what I said, most of the age related questions are pretty simple and trivial. It will not make too much sense. See, all right, let me take one variable and work it out. Let's say the mother's age and the daughter's age. Now look at the fraction, 1/5 of the mother's age, right? Now daughter's age is 1/5 of the mother's age. I will assume the mother's age to be 5x years. I will assume the mother's age to be 5x years. Why? Because calculation of 1/5 is easier. I told you that I'm going to teach you like this. You will never assume things as XYZ mindlessly. Whatever you want to assume, you got to do it little mindfully. That's the point I'm trying to say. You got to do it little mindfully out there. Okay, so mother's age is for 5x. Why did it take as 5x? Because the daughter's age is 1/5. While you are calculating the daughter's age, then you have to do 1/5 of the mother's age also. 1/5 of the mother's age. While you are writing your daughter's age, first you will be doing 1/5 of mother's age. Fair enough. And what? Daughter is 1 year more than. 1 year more than means +1. It's a lot easier. Therefore, you will say that the daughter's age is nothing but x plus 1 year. Daughter's age is nothing but x plus 1 years. Now, if you go to the first statement, pretty simple one. The sum of the ages of mother and daughter is 31. Fine. So sum is 31. Sum is 31. Therefore, 6x is equal to 30. When you solve this, you get the value of 6 is nothing but 5. The value of 6x is nothing but y. You get this x as nothing but y. 6x is 30. So therefore x is nothing but y. What is the age of the daughter? Already age of the daughter is x plus 1. X is not. X is nobody's age. X is nobody's age. Using x, I have to find somebody's age, right? X is nobody's age. The question is, what is the age of the daughter? Age of the daughter is x plus 1. We know x is nothing but 5. Therefore, the age of the daughter is 6 years. Alright, which is the answer to the given question. That is the age of the daughter. Okay, technically remember, try out on your own whenever you come across some of the age related question. Trust me, most of the simple age related question can be done with one variable. You don't even have to know through variables. Read stems carefully, make a suitable assumption at the right place after reading the question. With one variable, you can do most of the age related question. Okay, here let me come. Alright, here let me come. Alright, little bit of, at least let me introduce a little bit of criticality into this. Let me introduce little bit of criticality into this, because simple questions, I said that with one variable you can finish more often than not. Okay, let's take a look here. Let's take a look here. When I was, there is a person who is making this comment. When I was 3/5 of your present age, you were 1/3 of my present age. If my age after 4 years will be 40. The guy who is saying that, all right, the guy is saying that my age after 4 years will be 40. My age, all right, now that's where you start. My age after 4 years will be 40. My age after 4 years is 40 means what is the present age of the I? The fellow who is talking, let's say that his name is I. Alright, what is the present age of the I? Present age of I is 36 years, because after 4 years he is going to be 40 years. Therefore, what is the present age of this I? The present age of this individual is nothing but 36. Okay, then the question, after how many years your age, which means there is another person is commenting with already, he's explaining this to other person, right? What is your, when will be your age? After how many years from now will be your age be 40 years? That's a question. After how many years your age becomes 40? Okay, don't bother about that your age 40. First, let us crack the first part of it, because a lot of us will be stuck in the first part itself. Let's understand the first part of it. I was 3/5 of your present age. Remember this, guys. Another important thing. Try and make, in any critical problem, try and make the assumption in the present age scenario. Don't try to make it in the past or future age scenario. There are three parameters that you get: present, or at present, you may be talking in the present, or the author may be talking something about the past, or author may be talking something about the future. These are the three references. Take present as the reference. Alright, unless you're pretty comfortable, you can work already, you're good with numbers, good with logic, you can work with anything, right? Then you can take past or future as the reference. Alright, still, ideal way, the easier way to tackle is what? More often than not, take the present age as the reference parameter. Take present as the reference. What I meant, let's go here. So let me make a simple matrix. There is a I versus you. There is a I versus you. I is making statement to you and you is listening to his statements. I versus you. Let me take it like this: present versus past. Alright, this happened already. This is past. This is present. Present versus past. What I'm trying to say is, hey, whatever the assumptions you want to make, you better make it in these cells. Alright, always make the assumptions in present so that solving becomes little easier for us. Okay, now he was saying that when I was 3/5 of your present age. I was 3/5 of your present age. Let us say that your present age was X. Your present age is X. Alright, your present age is X. I was, which means I was 3/5 of your present age, which means in the past, I was 3/5 of your present age. I was 3/5 of your present age. That's the meaning of the first portion. First portion is assume in the present, assume that the present age of Y, is X years. Now relate with this statement. I was 3/5 of your present age. Therefore, you write it as 3/5 times of X. When? At the same stroke in time, because it's related with when. Condition, right? When you were at this point in time, you were 1/3 of my present age. You were means what? Past tense. You were is the past tense. You were 1/3 of my present age. Let's say my present age is X years. My present age is Y years. X is already assumed. Let's say that my present age is Y years. If your present age is Y years, you were means here. You were, alright, you were 1/3 of my present age. Good. You were 1/3 of my present age. That is the reference in the past. Alright, that is the reference in the past we are talking about. Guys, we know the value of Y. We know the value of Y. This is the value of Y. The I is saying that we said that let your percentage be y years. We went on to write the y years here, but we know the value of that y. Hey, what is that value of y? 36. 36. Therefore, I can write it here. Man, this is 36 here. This is 36. This is 36. You have to pay attention to the grammar in this question, otherwise you'll not be able to fill this, right? Yeah, 36. Hey, what is 1/3 of 36? You are writing 1/3 of 36. This guy is 12 years. This guy is 12 years at that point in time, right? This guy was, the other guy was 12 years at this point in time. Okay, so now what is that we know from here? We know that the difference between their ages is constant. What do you mean by difference between their ages is constant? 3 by 5x minus 12. I'm blocking the first sentence, guys. Here, what is the difference between their ages? The difference between ages in the first row, because in the past, sometime in the past, what is the difference between their ages? That is 3 by 5x minus 12. Because I know this value already 12, I don't have to write 1 by 3y. I can write it as 12. That is the difference between their ages. Hey, what is the difference between their ages in the second row? Already in the present, what is the difference between ages presently? It is 36 minus x. What did we learn? We said that the difference between their ages is constant. Whatever is the difference here, it has to be the same difference here. You can't say that, hey, in the past the difference between their ages is different from the present. No, difference ages can change, but the difference between their ages is going to be constant, which we know very well. Therefore, solve it. All the difference between their ages, I equate it. Therefore, you would say that 3 by 5x minus 12 is also nothing but 36 minus x. 36 minus x. Therefore, you would say that 18 by 5x. Get all x's on one side. Get all x's on one side. Therefore, 8x. 8 by 5x. Right? 8 by 5x is also nothing but get all y's on the other side. Get all constants on the other side. Which is nothing but 48. 48. Therefore, from here you get the value of x. You get the value of x from here. Right? Therefore, you will say that value of x is nothing but 30 years. The value of x is 30 years from here. Value of x is 30 years. Right, we'll solve this. We'll get the value of x. Right, value of x is 30 years. Now listen to me. What was the question being asked? Now go to the question, friends. Question is asking that after how many years will your age be? 40 years. Present age is 30 years. Present age is 30 years. Answer to this question: after 10 more years. After 10 more years, the age of this individual is going to be 40 years. Therefore, the answer for this question was 10 years. Alright, answer options will be there, or sometimes it will be a theta question. Alright, some of the exams have gone into the theta question as well. Right, in the theta question, that is type in the answer option. Theta questions, the box will be provided. You have to type the box. Inside the box, we will write it as 10. Right, inside the box, we will write it as 10. Okay, that's about this question. Right, that's about this question. Let's proceed. Let's proceed. I hope all of you got this. Paying a little bit of attention to the grammar will also make some sense. Right, paying a little bit of attention at times. Right, when the question issues get deeper, your reading speed, reading skills come in the picture. Your grammar skills come in the picture. Right, because for example, as we go along in some of the arithmetic topics, the train going, train coming, another person walking on the platform, there will be several words there. You will have 3-4 sentences, about 3 sentences. Sometimes people look at those 3 long sentences and drop this question. Problem, reading speed. Problem becomes reading speed, and hence ensure that your reading speed is also adequately built. Adequately built. So I was very surprised. Right, in one of the schools very recently, off late, they were taking about now what is the reading speed of some of the kids of the class 1 or class 2, some of the good kids. Now where there are reading labs, some of the schools which have the reading labs. For their surprise, they found out, of course, they are reading storybooks. They gave the storybooks. The average speed turned out to be somewhere about 300 words per minute. Can we imagine the 6-year-old kids or 7-year-old kids, about 7-year-old kids, this survey, 7-year-old kids were reading at 300 words per minute. Now, I don't want to comment about other kids there. What about the older kids? They can read at their level, some stories at their level. How much they comprehend does not matter, but they were capable of reading at 300 words per minute. All right, therefore, I'm encouraging you guys, let's all learn to read at certain speed. All right, there is certain speed which is expected at which we should read. All right, and the grammar elements of grammar, the vocabulary, all these play a role even in quant. All right, even in quant, all these things play a role. Don't neglect. Some people neglect that the quant and the reading is nothing to do with that. No, it's an expression of language that is still required for us. All right, let's proceed. Let's proceed. Let's move to the next question out here. Let's go to the next question. Let's take a look. Let's take a look. This is a beautiful question. This is a beautiful question. All right, for one of the topmost exams. Beautiful question. So I will give you about a minute's time. Organize this data. Organize this data before we go further. Quickly organize this. Let's try this. Let's try it out together. The average age of a couple was 24 years when the child was just born. All right, average of the couple. There is no child age here included, right? Child is just born. Just born is 0 years, right? 0 years. Unless the child completes 365 days, all right, the child is still considered as 0 years, right? Yeah, 0 years. Therefore, the question here, the average age of what couple? Only couple, husband and wife. Let me put it like this. The father, from the child perspective, I'm writing there is a father, mother, and child. Father, mother, and child. C is child. So, what is the average age of the couple? 24 years. I hope all of you have read the question completely out there. You would have read the complete question. The question is, what will be the age of the father? That is the question. When the child attains the age of the mother. All right. Let's put this to perspective. Child was 0 years. Let's say that the child was 0 years, mother was x years. Let me understand it. Mother was x years. Then the age of the father is going to be 48 minus x years. See, I said in most of the age related problem, you don't need two variables unnecessarily. You don't need too many variables out there. Yeah, how did you write 48 minus x? Because the average is 24. For how many people? Couple, only two people. Average of two people is 24. Then what is the sum of their ages? That is father plus mother. What is the sum of their ages? Their average is given. Father plus mother divided by 2 is 24. That's what is given to me. The average is 24. Therefore, their sum, father's age and mother's age, is equal to 48. Out of 48, I said that the mother's age is x. That's what I wrote. Out of 48, I said that the mother's age is x. Then the remaining is the father's age. Out of 48, if x is the mother's age, then 48 minus x is going to be father's age. All right, that's going to be father's age. So there we are, 48 minus x. These are the ages. Now what is being said? After how many years? This is the after how many years? After how many years the child will become mother's age? After x years. After x years. You are saying that after x years. After x years. Hey, why we are saying after x years? Read that. When the child attains the age of the mother, when the child attains the age of the mother at the time of its birth, at the time of child's birth. Hey, what was the age of the mother at the time of child's birth? X years. So when will child become that? For example, let us say that the child was 0 years, the mother was 25 years. When will child become mother's age? After 25 years. That is when the child will become mother's age at the time of birth, because child will never catch up with the mother's age. Mother's age at the time of birth, right? Therefore, after how many years? X long years. Therefore, plus x. You are adding plus x. Therefore, if you say that what is the age of the child? X years. Age of the child now after x years is going to be x years, which means everyone is growing too old by x years. This person, another x years get added. Or assume that after 10 years, let us say, then I should add 10 years to each one of them, but I don't know what is that. X years. All right, after x years, the other mother also will be growing old by x years. Great. Therefore, the mother's age will become 2x years. Right, the age of the mother would become 2x years. Fine. What about the father? Father also grows old by x years. Everyone will grow old by x years. Therefore, 48 minus x plus x. X and x are getting cancelled. Therefore, the age of the father is 48. Such a beautiful question. That was the answer here, because that is what has been questioned. What will be the age of the father? That was the question. Will be the age of the father. Age of the father is 48 question. Such a beautiful question. There is nothing here. You just have to understand that you got to learn to work with minimum number of variables. Don't create unnecessary variables and complicate the problem. Rather, simplify the problem when it is already in the simplest state. It's already in its own simplest state. Therefore, just take one variable and finish the deal. Just take one variable and finish the deal. Don't increase the variable, friends. Okay, these are some of the examples on the ages. Let me go to the next concept. Let me go to the next concept, that is on numbers. That is on numbers. I hope everybody is comfortable with ages. I took a couple of examples because it's not very complicated topic. One thing that you got to remember in the ages is what? The difference between the age of the individual. Whenever you are stuck, already unleash it by this point. Difference between the age of two individuals is constant. All right, that is one. Second thing that you got to keep in mind is, more often than not, one variable will be sufficient to deal with the problem. One variable will be sufficient. All right, if it is a simpler problem. Only in complicated problems we need more than one variable. Just keep these things in mind. You'll be able to work with the age related problems. Here we go. Let me take you to the next question. Let me take you to the next concept here. All right, concept built on the digits of the number. Technically, the 2-digit numbers and the 3-digit numbers. Let's first deal with the 2-digit number. Concept built on the digits of a number. So we all are aware. Let's say that AB is my number. Let me take that AB are the digits of my number. AB are the digits. It's a 2-digit number. Let me call this as a 2-digit number. First listen to me, then we will take a look at other part of it. Say I am writing a 2-digit number. 2-digit number, I represent it as AB. Let us say I represent a 2-digit number as AB. What is the meaning of this? What I meant here is, by writing AB, what I meant here is, this is a digit. Digit means it takes 1 to 9, because it's a tens digit. I said it's a 2-digit number. It's a tens digit, right? It is a tens digit. Therefore 1 to 9, because I can't write a 0 and call it as a 2-digit number, right? And then B, what about B? B can take any value between 0 and 9. B can take the value between 0 and 9. Therefore, all right, that is the units digit. Can the units digit be 0? Yes, units digit can be 0, right? Yeah. So therefore, already you write 0 to 9 and 1 to 9. Okay, this is very important. Some people get confused between 10th digit and 10th digit, right? There is a difference between 10th digit of a number and the 10th digit of a number. All right, now that comes in the decimal numbers, friends. Let me quickly illustrate that. So for example, if I write a number 123, all right, 0.45, if I write it like this, listen, all right, units and all right, this is the units digit. Units, it's S. Units. I'm sure all of you know this. But let me make it clear, because I also came across some of my students saying that, oh, I get confused, because in the question they use sometimes, already when you go deeper, they use 10th digit. They get confused. For them, 10th is also same, tens is also same. Hey, both cannot be same. They are different, right? This is the units digit. Now, what is this? This is tens digit. This is tens digit. However, this is 10th digit. This is called the 10th digit. TH. This is the 10th digit. This is the 10th digit. There is a difference, friend. There is no unit digit. Now you don't try to get creative by saying that, hey, there is something called as unit digit. No. There is a units digit, no unit digit, but there is a 10th digit and a 10th digit. Sometimes you will get this in the exam. While writing that, while explaining some decimal number, they will write like this and they will give a question built on that. Unless you understand what is the 10th digit and 10th digit, you will not be able to solve that, right? Okay. So now what is this one? This one is the hundreds digit. This is the hundreds. This is the hundreds digit, right? Yes, hundredths. Whereas this 5 is in that hundredth digit. This is the hundredth. Hundredth digit. This is the hundredth digit. Yeah. So okay, you may be clear. I just thought that, okay, because I was using the units digit, tens digit for the first time with you here in this lecture, I thought that let me make it clear. Okay, back to the lecture. Let's come back to the lecture. Right? Yeah. Let's be clear about hundreds and hundredth, tens and tenth. Right? Let's not be confused between them while we are using the language. Here we go. Fine. So therefore, now the 2-digit number is AB. So I have the units digit. I have the tens digit. Yeah, what do you mean by units digit? The place value is 10 power 0. What is the place value of this? 10 power 1. So therefore, what do you write? You can write AB as, because this is in the tens place. This is in the units place. What do you this is in the units place? What do you mean by this? You will say that this can also be written as 10 times of A added to, now 10 power 0 is what? 10 power 0 is 1. Therefore, added to 1 time of B, nothing but B itself. 10 times of A added to 1 time of B. For example, hey, what if my number is 23? Correct. This 23, this is in the tens place. This is in the units place. Therefore, this can be written as 10 into 2 plus 1 into 3. 1 into 3 is 3 itself. I will write it as 3 there. Okay, hey, what if I have a number 467? 467 now can be written as, this is in the tens units place, this is the tens place, and this is the hundredth place. All right, this is how my number is. So this can be written as, you can write this as 4 times of 100, that is 100 times of 4. Hundreds place, what is there in the hundreds place? There is a digit 4. Yeah, what is there in the tens place? There is a digit 6. What is there in the units place? There is a digit 7. Nothing but 467. 100 times of 4 is 400, added to 10 times of 6, which is 60, and added to 7. That is how you are getting the elements of 467. Okay, that's all I tried to explain here. Alright, that's all I tried to explain here. If B is the units digit, A is the tens digit, then that's how I tried to explain that AB can be written as 10A plus B. AB can be written as 10A plus B. Now let me come to the important point on that. This is not what I wanted to tell. Knowing this, therefore what? Alright, we know this, therefore what? Alright, now that is what we wanted to discuss out here. Let's try and understand this. What I wanted to do is, you get the 2-digit number and the digit formed by reversing its digit. I want you to remember one point very directly here. For example, let us assume that AB is the larger number. Let's assume AB is the larger number. I can write the number by reversing the digits. Alright, this is the number formed by reversing its digits. For example, if my number is 31, if my number is 31, let's say that my number 2-digit number is 31. For example, assume that A is better than B. AB is 31. AB is 31. Therefore, what is BA? BA is 13. That is all I'm trying to tell you here. Therefore, what is the difference between them? Difference is nothing but AB minus BA. The difference between them, or a difference between them, is nothing but 18. All right, now that's a point. Okay, firstly, I wanted to understand if there is a number, there is a number found by reversing its digit. Let's understand quickly. How do I write AB? Mathematically, AB is nothing but 10A plus B. Good. Hey, how do I write BA? BA is nothing but 10B. I'm writing B under B, friends. I'm just writing B under B so that calculations are easy. Of course, B is in the tens place. All right, but after I'm writing it as 10B. What about the value of A? Value is A is in the ones place. Therefore, A plus 10B. You write it as A plus 1B. Take the difference, friends. Take the difference. AB minus B. Take the difference between a two-digit number and the number found by reversing its digit. You are taking a difference here. You are taking a difference. You write it as 9A minus 9B. You write it as 9A minus 9B, which is nothing but 9 times of A minus B. Therefore, you say that the number and the number formed, difference between a number, what is my number? AB. The number formed by reversing its digit. The difference between a number and the number formed by reversing its digits is nothing but 9 times the difference between the digits. 9 times the difference between the digits. Now focus on my word difference. Focus on my word difference. When I'm using the difference, I don't know whether the number is better or the number found by reversing its digit is better. That I will not be knowing. Whether the number is better or the number found by reversing its digit is better, that I might not know. For example, when I say that, okay, my number is 23. My number is 23. This is my AB. Number found by reversing its digit becomes what? 32. All right, that becomes 32. The difference is 9. But the point is, I cannot, difference means positive. Difference. All right, difference between, if I say the difference between 3 and 10. Difference between 3 and 10 is 7. Even if I use the word difference between 7 or 10 and 3, difference between 10 and 3, order does not matter. That is also still 7. That is also going to be 7. Let's be mindful about the word, because sometimes authors use the word difference. There is no order. When they use the word difference, they meant that it is a mod. All right, now, so mod means what? Bigger number minus smaller number. Therefore, the best way to understand is what? Either A can be greater than B here. Either A can be greater than B, which means tens digit can be better than units digit, or units digit can be better than tens digit. So mathematically, to put it to the perspective, we write the difference like this. When I use the difference like this, people use the mod. Mod means what? Bigger number minus smaller number. Is AB big or BA big? I might not know. If you don't know, we will write it as a mod like this. When you write it as a mod, it will become 9 times the difference between the digits. Because is the digit A better or B better? I have no idea. Therefore, you write it as a mod. The word difference, technically, mathematically, becomes a mod. The word difference mathematically becomes a mod. Pretty simple ones, don't bother. Already you will be knowing what is the meaning of the mod. You know, A. What is mod of minus 3? 3. What is mod of 3? That's also 3. That's all the basic understanding of the mod. No big deal about it. There is no big deal about it, right? Let's not hype the things unnecessarily. That's all the meaning there. So that is the meaning of the mod. Difference means mod. Whenever authors say difference, understand that I want the positive difference between them. That's a basic portion of that, right? That is the basic portion of it. All right, let's understand. Therefore, I want you to remember this statement. I want you to clearly remember this particular statement. Difference between a two-digit number and the number found by reversing its digits is nothing but 9 times the difference between the numbers. 9 times the difference between the numbers. Let's go further, friends. Let's go further. 3-digit, or we'll see some other time. Let's take a look at this here. Let's take a look at one of the simpler questions. Some of the digits of a, let's see that. What is a simple question? Let's see. Or before we unleash to one of the exam related question, let's first understand this by using this. So what does author say? The sum of digits of a two-digit number is 6. Sum of the digits of a two-digit number. Let's assume that my number is AB. What author is trying to say is, look, A plus B is equal to 6. Very good. All right, this is what he is trying to say. If 18 is added to the number, if 18 is added to that particular number, there is already a number called AB. Author is saying that if 18 is added to the number, its digits are reversed. 18 is added to the number, its digits are reversed. Just analyze this. You have a number AB. You are adding 18 to this particular number, its digits are getting reversed. All right, its digits are getting reversed. Author is saying that find the number. All right, author is saying that find the number. Now listen carefully, friends. Therefore, BA minus AB is also equal to 18. Just bring everything on one side. Hey, this is nothing but what? This is nothing but difference between the number and the number formed by reversing it. Is it? Those who know the concept, you don't have to really solve anything here. You directly know this. This is nothing but the difference between a number and the number formed by reversing it. Is it? The reverse of the number is better. That's it. BA is better because you said that my number is AB. But when you looked at this equation, you are saying that BA is better. No problem. We will resolve this. Hey, what is this? BA minus AB is going to become? This is going to become 9 times of B minus A. 9 times of B minus A is equal to 18. That is what it will become. That's what we learned. That's what we directly learned. AB, all right, minus BA is nothing but 9 times the difference between the digits. A minus B. That's how we wrote, because we assumed that A is better. When A is better, that's what we wrote, A minus B. Hey, what if I write BA minus AB? BA minus AB, then you better write it as 9 times of B minus A. It's a well-known concept. If you know this particular concept, the moment you read this question, you would have arrived at this. You would have arrived at this. Therefore, you will say that B minus A is equal to 2. Therefore, you will say that B minus A is equal to 2. Now, look at the elements, friends. You have B plus A is equal to 6. You write B plus A is equal to 6. You write B minus A is equal to 2. Mental calculation, I already taught you here. Yeah, how do I get the value of B? 6 plus 2 divided by 2. How do I get the value of A? 6 minus 2 divided by 2. Therefore, the value of B is nothing but 4. The value of A is nothing but 2. The value of A is nothing but 2. What is the number here? AB is my number. All right, what is your number going to be? Your number is AB. Therefore, AB is nothing but 24. All right, therefore, the AB is nothing but 24. All right, that is what you are going to write this as. That is what you are going to write this as. Even quicker. Now, listen to me. Even quicker, listen to me. 18 is the difference. 18, 18 is added to the number. Its digits are going to be reversed. Nothing but the difference between the number and the number found by reversing its digit is 18. If the number and the number found by reversing its digits is 18, then the difference is 2. If the difference is 2, write the numbers quickly. You can write it to yourself. 13 is one of those numbers. 24 is another number. All right, 35 is another number, because you have the difference between the digits should be 2. The difference between the digits should be 2. So how can you write the 2-digit numbers? 13 is a number, 24 is a number, 35 is a number, but you wanted sum of the digits to be 6. Therefore, you can quickly do this. Even you can avoid this calculation if you are careful with numbers. And if you are good with numbers, the moment you understand the difference is the 6 can be kept in your mind. You can keep this number 6 in your mind and you can close it, because these numbers tick in your mind. What are the numbers that tick in your mind? 13 will tick in your mind because the difference has to be 2. So you will say that the tens digit should be minimum 1. 13 does not work because it is sum is not 6. Then you look for 24. It works. All right, therefore you are fine. The next also will not work because the sum keeps increasing, right? Yeah, so therefore you can hold some of the elements in your mind and you can try to do these kind of questions mentally. In fact, these questions, as you progress in your understanding, these things becomes the mental questions. Basically, you don't even have to write for it. All right, because when you get this 18 as the difference, you know that divided by 9 times of the difference is nothing but 18. So therefore this calculation of 2 comes right in your mind. All right, right in your mind, you get that 2. So difference has to be 2. If the difference is 2, these numbers will pop up in your mind. Is the 13 the answer? Is 24 the answer? Is 35 the answer? You will check with this 6. Whenever the sum becomes 6, that's going to be your answer. For now you write when you are learning. But the idea is you need to reach a process, already you need to reach a position where most of the processing happens in your mind, not on the paper. Not on the paper. The processing should take place in your mind. Right, that's a most effective, faster tool, not on the paper. Right? Yeah. Okay. Let's go to the next question. With that understanding, let's go to the next question. Let's go to the next question. Question here is, how many 2-digit numbers can be formed such that number formed by reverse such that the number formed by reversing its digits of the number is 27 more than the number. Reversing its digits is 27 more than the number. See, let me explain this question. Let the number be AB. Let the number be AB. Number formed by reversing its digits is 27 more, friends. Number formed by reversing its digits is 27 more. Author is trying to say, look man, BA is the number formed by reversing its digit. BA minus AB is going to be 27. Hey, what do you mean by BA minus AB? 9 times of B minus A, which is equal to 27. All this can happen in your mind. Therefore, you say that, look man, the difference between the digits is 3. You just have to write the set of numbers whose differences are going to be 3, in which B is bigger. You said that AB is my number, B is to be bigger. How much bigger? 3. Therefore, what is the smallest value you can take? 1. 1 plus 3, 4. Therefore, 14 is one of those numbers. right? Because B has to be 3 more than A. Therefore, what is the minimum value A can take? 1. Make the pattern 1. 14 is one of those numbers. 25 is another number. 30 solid 30 36 is another number. 47 is another number. 58 is another number. 69 is another number. Technically, you are trying to say that, okay, based on the given condition, I can form 6 2-digit numbers. I can shortlist 6 2-digit numbers. I can shortlist 6 2-digit numbers based on one simple tool. I told you very clearly that what are the tool that I am using? AB minus B. A difference between a 2-digit number and the number formed by reversing its digits is always divisible by 9. In other words, always divisible by 9, or 9 times the difference between the digits. This is the key element I am using in the last couple of questions, which is very, very important. Which is very, very important. Right now, that's important. Let's take another question. Let's take another question. So using that, all right, now you got this 3 here, and then you went on to make that projection, right? Make that projection. Let's take another question. Let's take another question. I'll give a minute's time. Think about it. I'll give a minute's time on this. Think about it. Okay, so two cases you get, right? As we might have understood, you will get two cases out here. How many 2-digit numbers can be formed such that the difference between 2-digit number and the number formed by reversing its digits is 45. See, basically I'm saying that your range is start thinking from 10. You can start thinking from 10, 10, 11, 12, like this. You can keep thinking up to 99. I'm saying that, man, you keep thinking up to 99, but you shortlist me some numbers in between this range. All right, 10 to 99. How many numbers are there? 90 numbers are there. From 10 to 99, if you count all the numbers, it would be 90 numbers, not 89 numbers. When I ask this question, some people get this also wrong. When I write all the numbers from 10 to 99, how many numbers are there? Some fellows will shout 89 also, not 89. Right now, it's a count. Count means you have to include 10 also. Difference is 89. What is the difference between 99 and 10? That is 89. That is 89. I never asked the difference. I said that fellow, I said that, man, count it. Counting is nothing but 90 numbers. There are 90 numbers. I am asking, out of these 90 numbers, how many numbers are there where the difference between the number and the number found by reversing its digits is 45? Reversing its digits is 45. Fine, let's understand this. It is possible that, all right, now AB minus BA is 45. AB minus BA is 45. In the sense, AB is the larger number, that's possible. Yeah, what is the second case? BA minus AB can be 45. BA minus AB can be 45, because after reversing the number can get better. Why the number should be better? The reverse of the number can be better. Correct. All right, now these are the two possibilities. But what are my numbers? My numbers are AB only. My 2-digit numbers are AB only. I am asking you to shortlist the 2-digit number. But the point is, after reversing the number can get better. So therefore, if the number is better, then it is AB minus BA. Yeah, what if after reversing the number is better? Then it is BA minus AB, because the reverse has got better. For example, something like 35, friends. If the number is 35, the reverse is better. 53, that is better, right? Therefore, what if the number is what is the number is 42? Number is 42, then the reverse is smaller. Reverse is smaller. Therefore, I will get two cases, because the author said the difference. Author used the word difference. Author used the word difference. Therefore, in this question, compared with the previous question, I will get two cases. I will get two cases here. I'll get two cases. Let me work on the first case. What is the meaning of the first case? The meaning of the first case is 9 times of B minus A is equal to 45. 9 times of B minus A is equal to 45. In other words, B minus A is nothing but 5. B minus A is nothing but 5. You are trying to say that B is 5 more than A. Fine, the minimum value of A should be 1. What is this B? B should be 5 more than A. Let us write it. Therefore, 16 is one of those numbers, which means while shortlisting, you shortlisted a number called 16. I'm saying that 10, 11, 12, like this, you go up to 99 and shortlist the numbers. You shortlisted a number called 16, right? You can also shortlist a number called 27. You can, because the difference has to be 5, you can shortlist a number called 38. You can shortlist a number 38. You can shortlist a number 49. You could shortlist 4 numbers out here. Come to the other side, friends. Let's come to the other side. What is that you are trying to write here? You are trying to write here 9 times of, all right, 9 times of, sorry guys, this is A minus B. This is A minus B. I already did the second part here. This is A minus B is this. Therefore, A minus B is 5. All right, A minus B is 5. So let us rewrite this. Difference between A and B is 5. That A minus B is 5. A is larger. A is larger. So start from writing the minimum value of A, minimum value of B. Right here 0. A should be 5 greater than B. Therefore 50. One of the numbers is 50. A should be 5 greater. A minus B is 5. When B is 0, A is going to be 5. Right? B is 0. A is going to be 5. When B is 1, when B is 1, sorry, A is going, when B is 1, A is going to be 6. That is when the difference is going to be 5. Therefore 61, 72, right? Then 83 and 94. All right, you will get 5 numbers. How many numbers you shortlisted? 5 numbers. Now listen to me. At this point in time, people can get a doubt as well. You may say that, okay, 50, how can this be? People get a doubt here. So 50, how can this be? What they do in their mind is they shortlist the number 50, they reverse it. When they reverse the digit, it becomes 05. Is the difference 45? Yes. I said that you shortlisted 2-digit number. Why you are bothered after reversing whether it will be a 2-digit number or not? Can I shortlist a number which is 50? Of course, yes, because it's a 2-digit number. What you are shortlisting is a 2-digit number. After reversing, is it becoming a 2-digit number or not? Don't bother about it. Why you are bothered about unnecessary things? All right, that is not necessary in this question. Did he ask that after reversing it's a 2-digit number? No, he is saying that shortlist 2-digit numbers. After reversing, will it become a 2-digit number or not? Does not matter. After reverse, you subtract and check whether it is becoming 45 or not. That is the crux of this, right? Now, therefore, some people get confused there. Okay, I clarified that confusion. There are 5 numbers. Come to the other side, my friends. Here, so BA minus AB is 45. How do you write? 9 times of B minus A is 45. From here, you say that B minus A is equal to 5. From here, you say that B minus A is equal to 5. Good. So B minus A is equal to 5, which means B is greater than A. What is the minimum value A can take? It can't take 0 now. It should be minimum 1. When you write it as minimum 1, then it is going to be minimum 1. So when you write it as minimum 1, then it is going to be 6 here. Therefore, you write the numbers. 16 is one of the numbers. 16 is one of the numbers. Say, what if I write 2 here? All right, therefore you say that the number is going to be 7. When I write 3 here, this is going to be 8. When I write 4 here, this is going to be 9. Right now, these are the 4 numbers. Basically, you are trying to say 16 is my number. Right? Number should be read like this. AB is your number. BA is not your number. Right? 16 is one of your numbers. 27 is another number. Right? 38 is another number. And 49 is another number. So you are saying that I got another 4 numbers here. So naturally, what's your answer? 4 numbers from this side and 5 numbers from this side. Therefore, you are saying that there are 9 numbers. Or there are going to be 9 numbers. 5 plus 4, 9. That is the required answer. There are 9 numbers out of 90 which satisfy the given condition. What is the condition? The difference between the number and the number formed by reversing its digit should be 45. The shortlisted numbers are this. You can say that 16 is one number that I'll shortlist. 16 is a number. 27 is a number. 38 is a number. 49 is a number. Likewise, 50 is a number. You are shortlisting 9 numbers for me. These are the 9 numbers which accommodate the given condition. I guess all of you are learning something, right? I guess all of you are learning something here, right? The word difference, the mod, the difference between a 2-digit number and the number formed by reversing its digits. All it is nothing but 9. All right, importance of that number 9, 9 times of the difference, right? How it is used in some of the entrance exams. All right, that's what we are learning. Let's go to the next part. Let's go to the next part. I'll give 30 seconds. Read it. Read carefully. Take 30 seconds. Read carefully. We are done, guys. 10 minutes, right? We are done. I always enjoy the last 10 minutes of the lecture, right? I know all right, because you guys enjoy, therefore I enjoy. I know that the students also enjoy the last 10 minutes of the lecture. They know that another 10 minutes they can change the activity. Last 10 minutes, get that fresh release of energy. What does it say? If a certain two-digit number is divided by the sum of its digit, the quotient is 2 and the remainder is 8. How do I express this thought? A certain two-digit number, let's say that my two-digit number is AB. My two-digit number is AB, right? A certain two-digit number when divided by 2, the two-digit number is divided by the sum of the digits. So what is two-digit number, friends? Already you are writing it as 10A plus B. All right, now when it is divided by, division algorithm, let's understand the division algorithm and directly write that. What is a division algorithm? If there is a number, if you divide it by a divisor, there is going to be a quotient and there is going to be a remainder. All right, there is going to be a remainder. So what is the meaning of this? Let's write it directly out here. So let us write it directly here. Your number is a two-digit number. So in place of number, you are writing 10A plus B, because AB is your two-digit number. Technically, you are calling AB as your two-digit number, 10A plus B. Then you are saying that, okay, this I am dividing it by sum of the digits. Hey, what is the sum of the digits? A plus B, that is my divisor, A plus B. So what is the quotient? The quotient is 2. Author has given the quotient is 2. Hey, what is the remainder? The remainder is 8. Hey, what is the division algorithm, friends? How do you write this division algorithm? How do I put it to perspective? From here you say that number is equal to D times of Q, divisor into quotient, divisor into quotient plus remainder. Division algorithm, where do you learn? Class 5. All right, class 5. Class 5 is the first time you learn this. Class 4 or class 5. All right, I'm sure by the time you become 10-year-old, you will learn this division algorithm. This is the division and this is the division algorithm. I will do precisely exactly same thing on this. I will do precisely the same thing on this. What is my number? My number is 10A plus B. I'm writing that. 10A plus B is equal to A plus B is the divisor. My divisor is A plus B. A plus B times of quotient. What is the quotient, friends? 2 plus what? Plus remainder. That is the given number. That's all author tried to tell in the first sentence. That is what he tried to tell in the first sentence. Simple, right? Division algorithm. That's what he tried to tell there. Okay, what is the second sentence? He's saying that if the digits of the two-digit numbers are interchanged and the resulting number is divided by the sum of the digits, then the quotient is 8. Now the digits of the number are interchanged. When the digits are interchanged, earlier your number was AB. Now the number is going to be BA. If the number is going to be BA, or let B is in the tens place, I will write it as 10B. I will write B under B. I will write A under A. Okay, that's my number. This time, second time, the number is BA, because AB I already wrote it here. So this time it is going to be BA. Now underlined in red, read it carefully. So it says that resulting number is divided by sum of the digits. Sum of its digit, again it is divided by sum of digits. Sum of digits is still going to be AB, because sum of the digits of this number is not different. It is going to be AB, right? The quotient is 8. The quotient is 8 and the remainder is 2. Quotient is 8 and the remainder is 2. Quotient is 8 and the remainder is 2. Now what do I do? Rather than subtracting, you add them. Alright, now that's what I said. Hey, look at the numbers and decide what you want to do. Look at the number and then decide. Don't decide whichever the way you want. Look at the number and decide. 8 plus 2 is 10, guys. 8 plus 2 is 10. Life is so simple, right? Therefore add them. If you add both of them, add both the equations. Therefore 10A plus 1A, it becomes what? 11A plus 11B. It is also nothing but 10 times of A plus B, because 8 plus 2 is 10 plus 8 plus 2 is 10. That's what you are writing. 10 times of A plus B plus 10 plus 10. That's what you are writing. What did you do? You added both of them. You added both of them. Therefore, what you are trying to say? You are trying to say that 11 times of A plus B, 11 times of A plus B is also nothing but 10 times of A plus B plus 10. 10 times of A plus B, 10. So go here, subtract it. Take this 10 onto the other side. You'll be left with A plus B is equal to 10. You'll be left with A plus B is equal to 10. Therefore, the sum of the digits, all right, now sum of the digits is nothing but 10. All right, that's what you are getting here. All right, that sum of the digits is nothing but 10. So once you get sum of the digits is sum of the digits is becoming 10. So therefore, all right, now what is the number that you are talking about? Sum of the digits of the number is 10, and the quotient part, you know. All right, you go to the first one, a certain two-digit number divided by sum of its digits. Sum of the digits is nothing but 10. The quotient is 2. Quotient is 2 means what, guys? 10, 2 times 20. Go here. A plus B value is known. This is the number. This is the number. Go to the first one. A plus B value is known. You don't have to know what is A and B. I already told you that also. Don't be unnecessarily worried about things. A plus B is 10. Just go here and substitute. What is A plus B? 10. 10 times of 2 plus 8. Therefore, the number is 28. Therefore, the answer is going to be 28, because A plus B is 10. 10 times of what? This is the number. Number is 10A plus B. Nothing but AB. AB is nothing but the number. Therefore, 10 times of A plus B is how much? 10. 10 times of 2 is how much? 20. 20 plus 8, 28. 20 plus 8, 28. See, you got to learn them, right? Because sometimes there will not be choices for such questions. Such questions come in the theta format. All right, such questions come in the theta format. Type in the answer. They expect that all right, there is a numeric. They expect that there is a screen keyboard which is given there. All right, the keyboard is given. You supply the numbers. You type this as 28. There will not be choices because some people while preparing they think that hey, anyway there will be choices. I will just put the conditions in place. I will pick the answer options by using the answer choices. Not necessarily. We know that most of the tests are moving towards theta questions as well. Of course, there are MCQs, multiple choice questions, but there are theta questions as well. All right, both go hand in hand. Therefore, I need to prepare conceptually from either perspective. If there is a choice, I will make use of the choice. If there is no choice, yet I'm ready with my concept. Right? That is the way you approach the questions. All right, here we go. Another type. Here we go. Okay, one type. All right, now this I will leave it to you. The difference between a 3-digit number, I want you to do this as a homework. Probably in the next lecture I will take it up. All right, while doing some other lecture I will take it up. Difference between a 3-digit number and the number found by reversing its digits. Difference between a 3-digit number and the number found by reversing a digit, friends, that's going to be 99 times of the difference between A and C. It is independent of B. I want you to go back home, write the steps for this. Difference between a 3-digit number and the number found by reversing its digits is 99 times the difference between the units and the hundreds digit. It is independent of tens digit. All right, yeah, let's come to the applications of that at a later stage. In some other class I will deal with this. All right, for now let's go to one last type. And we are done. All right, in the next couple of minutes we are done. So let's take this last type. 3 apples. So what is that author is trying to say? 3 apples. Read the question. Take a minute, just read the question. Right? Okay, let me take the price of apple as A, price of banana, price of grape as G. Therefore, 3 apples, 2 bananas, and 1 grape. That cost how much? 39 rupees. Okay, on the other hand, second proposition from here, 2 apples, 5 bananas, and 8 grapes. All right, and 8 grapes. All right, that costs how much? That cost 103. That cost how much? 103. The question is how much? What is the question? Question is what is the price of 3 apples, 3 bananas, and 3 grapes? All right, nothing but 3 times of apple plus banana plus grape. So one way, all right, now, so should I be finding out the value of A? Should I be finding out what is the apple price? What is the banana price? What is the grape price? That anyway you can't do, because what is the basic part of it? If there are two variables, you need minimum two equations. To solve it. For example, if I give 2x plus 3y is equal to 10, if I say that tell me what is x and y, you will not be able to tell. Man, I give two variables, you better give me two equations. Minimum two equations you should give, right? Then if I say that a 3x plus 7y is equal to 28, will I be able to do this now? Yes, you will be able to do this now. Now it is fine. Now you'll be able to do this. Two equation, two variables. Look here, there are three variables. If there are three variables, you give me two equations, and you are asking me, tell me all right now what will be 3 times of apple, banana, and grape. That you anyway can't do. This is another part of derived equation. I did one derived equation in the beginning. All right, I showed you one derived equation in the beginning. Now I'm doing another part. There is another part which I will come to it at a later stage. There is another part to this. These are the derived equation. What? The number of variables or more than the number of equation. I have three variables, but I have only two equations. Right? Therefore, it becomes a part of the derived equation. Now look, there is another pattern within this derived equation. Of course, this can be done by using plain derived equation, but there is another pattern that I want you to notice within this particular derived equation. That is the coefficients of ABC are in AP. The coefficients of A, B, and G are in AP. Look at the coefficients there. I just put them in the order. Even if the values were not given in the order, you can write them in the order. A under A you write, but just maintain that below A you write A, B, and G. Look at the coefficients there. They are in AP. What is the common difference? -1. 3 minus 1 is 2. -1. All right, that is becoming this. Okay, now look at the second line. 2, 5, and 3. They are also in AP. Sometimes you find all these special features, friend. All right, you find all these special features. Now these fellows are also in AP. When this happens, all you got to do is multiply them by the reverse coefficient. Just go here, multiply by the reverse coefficient. What is this? Reverse. All right, multiply them the reverse differences, common difference. What is the common difference here? 3. What is the common difference here? 3. Go and multiply the first equation by 3. All right, yeah, what I should be doing in the second one, you multiply. I'll multiply it by the common difference of the first series. What is the common difference of the first series? Multiply this by 1. All right, multiply this by 1. Now listen to me, all of you, very carefully, friends. All of you listen to me very carefully here. All right, by doing this, what will happen there? Right, but by doing this, what will happen? Right now, just take a look at this. 3 times 9. All right, 2 1 time 2. 9 plus 2 has become how much? 11. Right, 9 plus 2 has become 11. That is the total coefficient of A. Let's go to the next one here. 3 2 times how much? 6. 5 1 time how much? 5 1 time how much? 5 1 time is 5. What is 6 plus 5? That also has become 11. In other words, let me write it for you. All right, let me write it for you one last time. Let me write it. So multiply this by 3. When you multiply this by 3, call this as equation 1. I'm writing 1A for you. That is 9A plus 6B plus 6B plus 3G is equal to 3 times of 39 right now, which is nothing but 117. What did I do? This is my 1A. This is my 1A. I just multiplied it by 3. Okay, come to the second point there. Come to the second point. This will be 2A plus, all right, sorry, 2A, because you are multiplying by 1, therefore all it is 2A. 5 times of B becomes 5B. This becomes 8G is equal to what? 103. Now look at this. You may be wondering, hey, there is a minus 1, isn't it? There is a minus 1, isn't it? Why you are doing this? Yeah, so minus I'm ignoring. Of course, one common difference should be positive, one common difference should be negative. Only then this technique works. Only then this technique works. If both are positive, it will not work. If both are positive, it will not work. Now do what? Now add. Now do what? Add them. If you add them, you are getting it as 11 times of A plus 11 times of B plus 11 times of G is nothing but 220. Therefore, A plus B plus G, well, at one set of A plus G, B plus G is 220 divided by 11, which is becoming 20. But what author wanted? He wanted 3 sets. He wanted 3 sets. 3 sets is nothing but 60 rupees. 20 into 3. Therefore, the 3 sets is nothing but 60 rupees. Okay, take a look at this question once again. Let's quickly take one last look at this question once again here. All right, let's take a look at this. So what is that we are trying to say here? Write the elements in such a way that there may be sometimes AP, observe it. Right now you have wrote them. The coefficients are in AP. The first line is also in AP. The second line is also in AP. When one, the common difference is negative because it is decreasing AP. The first one is a decreasing AP, friends. This is decreasing. The second one is an increasing AP. One of them should be decreasing AP. One of them should be increasing AP. In that case, multiply them by the reverse differences. Multiply them by the reverse common difference. Multiply them. There is a minus 1 here. Multiply that. Already minus is not required. One has to be increasing AP. One has to be decreasing AP. Ignore the signs. Ignore that plus and minus. Just multiply by the reverse. Reverse common differences. When you multiply, you get 1A and 2A kind of equation. So here always they match. The numbers match. You get the derived equation. That is another part. I actually spoke about today 2 types of derived equation. One in the beginning, one towards the end. I'm closing with the derived. I'm closing it with another derived equation. So of course there is another types. Another few types that we will come to it as we proceed with our lectures and the discussions. I hope most of you appreciate and you enjoyed these lectures. You learned. Enjoyed in the sense I meant that you learned. But remember this. Remember this, guys. This is very important. When you listen to me most of the time, right now in this 120 minutes, in the last 120 minutes, I was doing all the talking. What you are doing, you are absorbing it. You are absorbing it, which means I was touching your brain. Transformation did not happen. Only touch. Transformation did not happen, which means some of them have not become your own tools. They were my tools, right? When it will become your tools, when you practice them repeatedly. Therefore, remember, go back to the modules, go back to the books that you have. These are the study material. These are the whatever the modules that you have. Go back and practice. Use some of the applications that you learned today. Right now, here we go. I will see you with another lecture very soon. Bye till then. Take care.